सुरती विनू भाई।
हाँ बोलो हेमंत भाई।
क्या चालू थे कि नहीं क्लास? ट्रेनिंग चालू थी कि नहीं?
5 मिनिट પછી ચાલો, 5 મિનિટ પછી ચાલો.
ओके ओके ओके।
ઓકે.
म्यूट करके आप जो बोलिएगा उसको।
गुड मॉर्निंग टू ऑल। माई सेल्फ मोहन चौरसिया, एसएससी टेली कैमटेक। जो आज का हमारा वेबिनार का टॉपिक है वो एसडीएच टेक्नोलॉजी एंड तेजस STM 1/4 है। जैसा कि हम लोग देख रहे हैं कि अपनी इंडियन रेलवेज़ में ज़्यादातर सेक्शन में तेजस के STM लगते जा रहे हैं, इवन लग भी चुके हैं और काम भी कर रहे हैं, लेकिन अपने स्टाफ को काफ़ी हद तक दिक्कत भी आती है और कुछ लोग अच्छे से कर भी पा रहे हैं। तो आज उसी लिए हमने ये वेबिनार ऑर्गेनाइज करवाया है और हमारे साथ तेजस नेटवर्क के एग्जीक्यूटिव भी जुड़ चुके हैं, मिस्टर विवेक कपूर जी और सतीश यादव जी। तो मैं विवेक कपूर जी से बोलना चाहूँगा कि अब स्टार्ट करें। आई थिंक जो है लोग जुड़ चुके हैं और भी आना होंगे तो आ जाएंगे 10-5 मिनट में, लेकिन हम स्टार्ट करते हैं। ठीक है विवेक जी, चालू करिए।
देखना था ना सर, आपका फोन आया था, कॉल पर जाके देख लेते हैं। गौरव सर ही कहते थे कि चलते हैं ऐसे।
ओके मोहन जी, मैं स्टार्ट करता हूँ। जस्ट गिव मी 2 मिनट्स, मैं स्लाइड्स अरेंज कर रहा हूँ।
हाँ तो एक बार आपको कॉल कर देंगे, हम बता देंगे कि आज मतलब 2-3 बजे।
Vivek, are you there?
I'm starting, just wait a minute. Hi everyone, can you see my screen, Mohit?
Yeah, yes, I can see.
Okay. Yeah, hi, welcome all.
Mohanji, are you able? Mohanji, are you able to see the screen?
जी जी बिल्कुल दिखाई दे रहा है।
Okay. So I hope all are able to see. Huh?
जी जी बिल्कुल।
Okay.
So yeah, thanks Mohit.
Sir, not visible proper not visible, sir. Sir, slide proper not visible.
It's visible.
अच्छा, क्या सभी लोगों को प्रॉब्लम आ रही है कि केवल जी के निर्मला जी को समस्या आ रही है?
No, actually, there may be some network issue there at GK Nelaji location.
No, sir. Network is okay, sir.
If most of the people if are able to sing, then definitely there will be no any issue. So majority
Sir,
is
we are
on
able to see.
swing side, right?
Yeah, we can see. We can see.
Okay.
So I'll just share it again. मैं एक बार stop करके दोबारा on कर देता हूँ.
Yeah.
Can you see the screen now?
बिल्कुल बिल्कुल दिख रहा है, आप आगे बढ़िए.
Yeah, please go ahead, Vivek.
Okay. Yeah. Thank you, Mohit, and thanks, Mohanji. So just request everyone to be on mute so that other people can also, listen to it properly. Otherwise, it will be very disturbing. So I'll just start with the.
मेरा साउंड मिल रहा है?
हाँ जी मिल रहा है विप्लव राय जी, आपका साउंड मिल रहा है.
Thank you, sir.
So I just request everyone to be on mute. So and whenever there is some query, you can just raise it straight away. But otherwise, be on mute so that others cannot do not get disturbed by this. So I'll just quickly cover the what is SDH technology. Why do we need SDH technology?
लिख दिया ने क्या बोल
Yeah, request you to please mute all.
Maybe a moderator, who's the moderator, I can mute everybody and then rest of the people. Okay. So I'll just start with what is the SDH technology. Okay, why do we need the SDH technology? So I'll just start from there. Okay, so predecessor of SDH, like before SDH, what we have in 1960s when the communication system was being developed, so we used to communicate using the PCM technology, which was pulse code modulation. Okay, although it was like limited to a very small bandwidth, so then there was a requirement of having the larger bandwidth was understood, and a new system was developed which was called as a PDH. So PDH here stands for the please synchronous digital hierarchy. So please synchronous stands for the it is almost synchronous. It was not synchronous perfectly. It was almost synchronous. That means, so when we send some bits from one node to other node, okay, so that needs to be having the same clock frequency. If the clock frequencies are different, then they will receive a bit at the different time, and they'll not be able to comprehend the signal. So the signal needs to be synchronous to each other. Every node needs to be synchronous to each other, running on the same clock. So now in the PDH, it was understood that the system needs to be synchronous. So every system used to have their own clock. Okay, so when every system was having its own clock, so but there was no reference clock, there was no central clock through which all the systems were running. So this was happening that the systems were almost synchronous to each other, but they were not perfectly synchronous to each other. So in this PDH, we used to have the communication using the microwave or the fiber optics. So where the least signal was 2 Mbps. And 2 Mbps signal used to get multiplex. By multiplexing 2 Mbps signal, we used to get 8 Mbps and then 34 Mbps and then 139 Mbps. And then 565 Mbps. So the limit of PDH was up to I guess it was up to 34, 35 Mbps. Beyond that, we were not able to get the signal. So now in Word, we are following two standards. One standard is called SONET, and another standard is called SDH. So it is like that America and Japan, they follow the SONET standards, and their basic bit rate start from the 1.5 Mbps. Okay, and rest of the world, including India and Europe, we follow the European standard, for which the minimum bit rate is 2 Mbps, and it goes further multiplexed into 834 and 140 Mbps. However, America and Japan, so they used to have the primary rate of 1.5 Mbps, what we call as a T0, and the SONET system was developed based on these. So their multiplexing gets different. It is like from 1.5 Mbps to 6 Mbps into 44 Mbps. So this all was PDS technology. Now it is gone. So we found out that in the PDS there were some challenges. Like I told you, there was a maximum capacity limit of 566 Mbps in the PDH. We cannot go beyond that. System developing, the networks were growing, so we wanted to have a technology which goes beyond 566 Mbps. Okay, and in the PDH, there was only the point-to-point communication was like if the one signal goes down, other signal we cannot have the ring protection, we cannot have the another path through which we can get the signal. So PDH was only the point-to-point configuration, and with the growing system, it was the need was understood to have a ring kind of architecture over there, so that if there is a cut in the one path, other path can take over. Also, so the PDH systems were getting the vendor dependent. Like if there is a vendor X to which you are buying the PDH system, it will not interrupt the vendor with the vendor Y. So that is a main challenge, and every vendor was having the monopolies in their respective customers. So you cannot place another vendor's equipment in the network. So that is why PDH was a limiting factor. It was, there was need of to develop this PDH to there was to PDH to SDH. Okay, so now the pattern was sorry. So pattern was handed over to SDH by the PDS system. So earlier the PDS systems were there. So now it was handed over to the SDH systems. Okay. So slowly the PDS system started taking over the SDH. So what is the difference between PDH and SDH? So SDH is a synchronous technology. SDH stands for the synchronous digital hierarchy. Here all the nodes in the system in the network are synchronous to each other and managed by a single reference clock. So there is a reference clock in the SDH systems, and all the nodes get the clock from that reference clock, and all the nodes are synced according to that, so that there is no gap in the synchronization, and the data communication can be smooth. So here, if you want, I can read out all the differences, but I already explained. So like reference clock is not synchronized, and the reference clock is synchronized in the network in the SDH. So in the synchronization, there is a payload and the frame in the PDH and the SDH. So there was no synchronization in the PDH frame, payload and the frame. But in SDH, we covered up that gap, and the synchronization starting happening between the payload and the frame. So both were synchronized to each other. Okay, and in this, as I told you, the data rate maximum was 566 Mbps. But in SDH, we can go up to 40 Gbps, which is STM256. We can go up to this much rate. And then another problem which was solved through PDH is the universal standard was missing in the PDH, but in SDH there was universal standard. So there was a ITUT standards which was developed by the ITUT, and every vendor has to follow those standards to make the SDH systems. So that is why SDH system are working with each other. So for that so there is no vendor locking, there's no vendor specking over there. So for that, SDH systems are there. So what is different in SDH? So as I explained you, that ITUT developed this SDH technology, and every vendor whosoever is developing the SDH technology has to follow the ITUT standards to be in the system. They cannot have their monopoly in the market. So in SDH, every frame, the duration of every frame is like 125 microsecond. In 1 second, you get 8,000 frames for the SDH for any line rate, be it STM1, STM4, STM16. So you get 8,000 frames per second from the SDH technology. So it is used by using the multiplexing of the data. So what else is added in the SDH? So one of the major advantages what was added in the SDH, and what I also urge railways to use, is the OEM functionality and the DCC functionality. That means remotely you can configure the nodes by using a central management system, and you can do all the OEM functions through that central management system. So in this, in the frame, we added some bytes. There were some bytes added, which I will explain later. And purpose of those bytes were to do the OEM operations. Like there are bytes for frame alignments, that FVS frame alignments sequence A1 byte, and then there is a bit parity checking byte which checks the BR errors, the B bytes, and there are like many bytes in the SDH frame. I will explain it later. But those bytes were used for the OEM functionality of the SDH. Okay, so this was the main advantage of the SDH, and by using the remote management system, you can configure anything and everything on the system by sitting at a central place. You need not to visit the sites. So this is the merit of the SDH, and it can obviously operate in the multi-vendor and multi-operator environment. That's already explained. So how the multiplexing is happening in the SDH? Okay. So here I'll start from the container 11. This is the payload what you get from your clients. Okay, that so some bytes are stuffed into it, which gets into the virtual container. So this is the payload, actual payload. Okay, and then it gets converted into the TU11s and the TU12s. So all the three TU12s gets multiplexed, and one TUG2 is formed. So this is the internal mapping of the multiplexing of the SDH signal. You don't have to do anything in the system. This is how the SDH technology works. And then these 7 TUG2s multiplex to each other and make the VC3s. Okay, and then some pointers are added in the VC3s, which makes it the AU3, and then 3 AU3s are multiplexed again to each other and make the AUG1, which again is by adding some bytes converts it into the STM1. Similarly, if you add multiplex more AUGs, so it will be the STM4 signal, STM16, STM64, goes up to the STM256. So this C12 is the E1, what you generally called as E1 is the C12 comes in the C12 container. Or you can directly have other payloads also, the C3 payloads, which is like TU3, which is for 21 E1, what you call as E3. So this comes in the TU3 and TUG2 and converts into the STM1. So all kind of payloads are there. Okay, so right, starting from the E1 goes up to the VC. This E3 and C4 is the STM1 container, which directly converts into the VC4 and then converts into the STM4. So these C4, 4C. So this 4C stands for the concatenated signal. So here 4 C4 containers get concatenated to each other and converted into the C4. It is for getting the STM4 directly. Or if you want, there is a requirement of STM16, then there is another level of complexity to it. I will not go into all those details, but for you guys, it is understood. You need to understand the C12 is the E1, which gets start, and then by adding some pointer and some bytes into the frame, it ultimately gets converted into the STM1. So if you'll see 7 into 3 into 3, which comes out to be 63. So in STM1 frame, you'll have the 63 events, and all the events are numbered by using the KLMs. So KLM number starts from 1, and L stands for the middle one for the set, goes up to 7, and then M stands for the multiplexing. Again, it goes for the 3. So the number starts from 111, goes up to 373. So these are the 63 ones in the STM1 frame. So these are the different bit rates.
मगजमारी करते मेरा जो पूछता ही नहीं, मैं अगर सिंगल आता ना तो मैं इनको डालता और
So different SDH bit rates. For STM1, so it is 155 Mbps. STM4 is 622 Mbps. This was the limiting factor for the PDH, mainly this 556 Mbps. So then beyond this is STM16, which is 2.5 gig or 2400 Mbps, and then STM64, which is 10 gig or 999 53 Mbps. So in STM1, as I explained, there are 63 events. In STM4, you just multiply it by 4. So there will be 252 events. And in STM16, you just multiply this 63 by 16, you get 1008 events. So like this in STM64 multiplied by 64, you get these many events in the STM64 also. So this is the basic bit rates what are there in the SDH. So I guess you guys are using the events STM1 and STM4s and sometimes STM16 also. So these many events you can map in the STM1, 4 and 16. So this is a very, I'll not go into details of every bit and byte here, but this is a very high level of SDH frame, what I told you. So it is having 270 columns and 9 rows. Okay, so these all bytes which are written in color are different bytes used for the different purposes. And this green one is the payload, where your actual payload comes from the client. And then these are the pointer bit, which helps in the adjusting the frame into the bytes into the frame according to the synchronization requirement, whether you want to have a if the synchronization requires frame to be adjusted with some bytes, so you need some stuffing bytes. So this are used by using this path overhead functions. And then there are other details to it. If you want, I can go into the detail. but I'll mainly explain you the. So what is this ROSO MOSO in this? So this RSO stands for regenerator section overhead. So from point A to point B, or point A to point C, you're having some signal, and it needs to be regenerated at point B. Okay, so from A to B, these overhead bytes will work, and from A to C, these MSO bytes will work. And end-to-end path, like from signal starting from where and then terminating at where at other locations. So this path overhead bytes will work over there. So these different bytes have different functions, like in from T1 to D3. Yeah, sir, you had just to
Sir, your voice is not coming. Your voice is clipped.
हेलो
Your
विवेक
voice
जी,
is
आपकी आवाज़ नहीं आ रही है, थोड़ा
आवाज
चेक करिए।
थोड़ा सा रिपीट कीजिएगा।
हेलो मोहित जी, आई थिंक आप थोड़ा विवेक जी से संपर्क करें, आवाज़ नहीं आ रही है।
मैं एक बार सर बात करता हूँ, एक बार हो सकता है नेटवर्क का कुछ इशू है, मैं एक बार बात करता हूँ।
ठीक ठीक।
हेलो, आवाज नहीं आ रही है? सर आवाज नहीं आ रही है।
हाँ हाँ, अभी थोड़ा कुछ टेक्निकल इशू हुआ है, अभी उसे रिजॉल्व करते हैं, अभी 2-4 मिनट में भी आते हैं, है ना?
हाँ सर, वो उनका एरिया में कुछ नेटवर्क का इशू है, वो एकदम से उनके कनेक्शन चला गया,
जी
वो
जी
दोबारा
जी,
से कनेक्ट हो रहे हैं।
ओके ओके ओके, ठीक ठीक। मैं सभी लोगों से कहना चाहता हूँ कि थोड़ा टेक्निकल इशू हुआ है, इंटरनेट का प्रॉब्लम हुआ है। विवेक जी अभी जल्दी ही हमारे साथ जुड़ेंगे।
Hello, Mohit, I'm audible now?
हाँ हाँ बिल्कुल, आपकी आवाज़ आ
Yes,
रही है
yes,
विवेक जी।
yes.
I'm extremely sorry. I just
ओके
got some
ओके
network problem at my end.
ओके ओके, कोई
I'll
बात नहीं।
just share my screen.
Yeah, you just please continue. No issue.
Can you see my screen, Mohit?
Yeah, yeah.
Okay. So what I was explaining that in SDH, so this is standard SDH frame for every data rate, whether it is STM1, 4, 16 or 64 or 256. So this is the frame what is being used. So in this SDH frame, the green color is the payload. So this is the actual payload or actual traffic what we carry through the SDH. So that fits into this green area, and then there are, this is a blue bytes are called RSH. This is regenerator section overheads, and then there is a multiplex section overhead, which is a which are orange bytes. So what do you mean by regenerator section and multiplex section? I will explain in the further slides. And then there are path overhead bytes, which are dark blue in color. So these are bytes which help in SDH technology for the end-to-end OM of the path. So I'll explain what do you mean by RSH, what do you mean by MOSH, what is PO, path overheads. I'll explain in the, so but just for a very high level, it is a 270 column and the 9 rows SDH frame, what is being repeated at every 125 microsecond or by 8,000 times in a second to get the data rate. So what do you mean by overhead bytes? What I was talking is the overhead byte. So like if you want to carry some,
सर सर अच्छा से एक्सप्लेन करिए थोड़ा स्पीड कम करके
okay,
और हिंदी इंग्लिश दोनों में थोड़ा सा एक्सप्लेन करने की कोशिश करिए
sorry,
हिंदी इंग्लिश में भी मतलब हिंदी में
अच्छा
भी थोड़ा सा
ठीक है मैं हिंदी में ही कर लेता हूँ.
ओके ओके प्रवीण जी, ठीक है,
मैं हिंदी में ही बोल लेता हूँ. सो इसके अंदर हमारा एसडीएच फ्रेम है जिसके अंदर 270 कॉलम है और 9 रोज होती है. ठीक है. अब इसके अंदर हमारे पास रीजनरेटर सेक्शन होता है और एक मल्टीप्लेक्स सेक्शन होता है जो कि डिफरेंट बाइट्स और डिफरेंट सेक्शंस में काम करती है. सो इस रीजनरेटर सेक्शन का क्या मतलब है, मल्टीप्लेक्स सेक्शन का क्या मतलब है?
Your speech is very low, sir.
What is low? It is
Sir,
low.
it is very low, sir.
अच्छा निर्मला जी, आपको मेरी आवाज बराबर आ रही है?
क्लियर है सर?
अभी तो
Now it's clear, sir. Okay, sir. Now clear.
सर वॉल्यूम थोड़ा बढ़ा दीजिए.
एकदम क्लियर है.
ओके, सो मल्टीप्लेक्स सेक्शन क्या होता है ये मैं आपको आने वाली स्लाइड्स में बताऊंगा. रीजनरेटर सेक्शन क्या होता है मैं अगली स्लाइड्स में आपको बताऊंगा. बट अभी आप याद रखिए,
not conversant with Hindi. Okay, better to explain in English only. There are so many South Indian.
अच्छा विवेक जी,
मोहन जी, it will be difficult.
हाँ या आप
सिंगल प्लेटफॉर्म.
बिल्कुल आप ये काम करिए, थोड़ा वो मिक्सअप ही चलने दीजिए, थोड़ा वो बेटर रहेगा.
Okay, sir, I've already explained this slide in English, but I'm just trying to explain this slide in Hindi now. Okay, so this MSO और RSO क्या है मैं आपको आने वाली स्लाइड्स में बताऊंगा. So like this, we have a payload. Okay, so payload is your actual traffic, actual client traffic. What you have is called the payload. Okay, so in this we carry this payload using the overhead bytes. So जब ओवरहेड बाइट्स को हम यूज करते हैं, हम इस पेलोड को कैरी करते हैं अपने क्लाइंट ट्रैफिक को. कैरी दिस क्लाइंट ट्रैफिक यूज द ओवरहेड बाइट्स. लाइक इन ए ट्रक वी हैव डिफरेंट कंटेनर्स. हमारे पास डिफरेंट तरह के डब्बे होते हैं एक ट्रक के अंदर. हमें जब कैरी करने होते हैं हम उन सबको कैरी करते हैं पेलोड के अंदर. और जो ओएम बाइट्स जिसको हम बोल रहे थे आरएसएच एमओएसएच, उन सब सेक्शंस को हम so this is like the truck which is having the driver of the truck is there. So ये इस frame को चलाता है. So this overhead bytes these carry the frames along with the payload. So इसको complete उसको बनाने के बाद हमारे पास overhead bytes और payload आता है. So I in this slide I will try to explain how do you form STM1 using from the E1 or from the C12. So C12 एक कंटेनर है, उसमें हम STM1 कैसे फॉर्म करते हैं मैं उसको बताने एक्सप्लेन करूंगा. So this is a C12 container. This is the E1. ये E1 है जो आप, so ये E1 है कंटेनर 12 के अंदर आप क्लाइंट ट्रैफिक E1 का आता है. उसमें कुछ पाथ ओवरहेड बाइट्स ऐड हो जाते हैं और कुछ पॉइंटर्स ऐड हो जाते हैं. So we add some path overhead bytes and some pointers in this container. और वो उसको हम जो इस पूरे को जब हम बाइट्स ऐड करते हैं and when we add these bytes this becomes TU12. So इसको हम बोलते हैं ट्रिब्यूटरी 12 TU12. So 3 such TU12s, 3 ऐसे TU12s combine होकर एक tug2 बनाते हैं, which is what we call as a tug2. So these 3 TU12s gets combined and form one tug2. and these 7 tug2s get combined and form one tug3. So जब ये 7 tug2s combine हो जाते हैं तो एक tug3 बनाते हैं, और जब 3 tug3 combine हो जाते हैं तो वो आपका STM1 फ्रेम बन जाता है। और फिर उसके अंदर आपके पाथ ओवरहेड बाइट्स, पॉइंटर बाइट्स एंड सेक्शन ओवरहेड बाइट्स ये ऐड होते हैं। सो यू ऐड दीस ओवरहेड बाइट्स इन दिस एंड यू फॉर्म वन कंप्लीट STM1 फ्रॉम द इवन्स। सो अगर आप देखोगे इवन के अंदर यहाँ पर एक इवन है, यहाँ पर इसके अंदर 3 इवन आ गए, यहाँ पर 21 इवन हो गए 60 टग 2 के साथ, और यहाँ पर 63, बिकॉज हर टग में 21 इवन है तो 3 टग हो गए तो 63 इवन होकर आपका STM1 बन गया। So in English, we have one container. So we have 3 TU12s. So 3 evens comes here, and then 7 such tug2s. Okay, are there? So in each tug2 there are 3 evens. So total 21 evens are here at this point. So in each tug3 we have 21 evens, and 3 such tug3s gets multiplexed and form 63 evens in one STM1 frame. So in STM1 frame, we have pointers and the path over bytes and the section over bytes get added to form the STM1 frame. So this explains how the even gets 63 events get mapped into the one STM1. So ये explain कर रहा है कि कैसे एक कंटेनर, कैसे एक इवन 63 इवन से मिलकर एक STM1 बनाता है. So yes, this slide is depicting that. So I was talking about RSH, MSH में हम उसके बारे में पिछली स्लाइड में बात कर दे. RSH क्या है, MSH क्या है. Okay. So this is the PDS signal और कुछ कोई client signal आता है SDH के अंदर, MUX के अंदर. So when this PDS signal comes in and this is the PDS signal which is getting out. So हमें signal को we have to carry the signal from this end to this end. हमें यहाँ से यहाँ signal को लेकर जाना है. तो इसको हम बोलेंगे path. So जो path overhead bytes है वो जैसे B3 मैंने बताया था, तो वो जो path overhead bytes will work for this end-to-end path. Okay. Then there are sections जो कि distance ज्यादा होने की वजह से हमको सिग्नल को रीजनरेट करना पड़ रहा है, ठीक ना. और यहाँ पर हमारे दूसरे मक्सेस भी लगे हुए हैं. सो जहाँ पर हम सेक्शन को रीजनरेट कर रहे हैं, इनके बीच में हमारे को बोलते हैं रीजनरेटर सेक्शन, विच इज लाइक RSH, जिसमें कि B1 बाइट हम की बात कर रहे थे, जो B1 बाइट्स थे. और जो मल्टीप्लेक्स सेक्शंस हैं, विच इज फ्रॉम जो यहाँ से यहाँ है, जहाँ पर सिग्नल ड्रॉप हो रहा है मल्टीप्लेक्स सेक्शन में, सो उसको हम मल्टीप्लेक्सर सेक्शन ओवरहेड बाइट्स बोलते हैं. जैसे कि B2 बाइट थी उस फ्रेम के अंदर, वो इस सेक्शन के अंदर काम करती है. जस्ट टू एक्सप्लेन इन इंग्लिश, so we have a PDS signal which is from end to end. Okay, so now this PDS signal, which is from like for an example, let us take it from it starts from Delhi and it goes up to Chennai. So from Delhi up to Chennai is the entire path of that signal. So if this is the path, then the path overhead bytes will come into the picture. Now you start from Delhi and you want to drop some bytes at the Bhopal location. You want to drop some traffic, you want to add some traffic, but still you do not need to regenerate the signal because distance is small. So this, whenever you add some or drop some traffic at some location, that is called the multiplex section, where the multiplexing happens and the demultiplexing of the signal happens. So that becomes a multiplex section. Suppose now from Bhopal up to Chennai, you cannot carry the signal because yes.
Hello. Sir,
Yeah.
Sir, after the first segment, there is one regeneration section. Okay, it is only for the purpose of repeating all the events, no add or no drop. Then after that, that OXC or DXC, what is that, and what is the function of it? Some cross sign is there.
Okay, I'll explain. So whenever yes.
That one.
So regenerator and multiplex section, it works where you are multiplexing or demultiplexing the signals. So that is called the multiplex section. Since when you demultiplex the signal, it also gets sort of converted into the electrical domain again, and then again if you want to carry it further, then again it gets converted back to the optical. So this kind of signal is called the signal is getting regenerated in some form here. Like from Delhi to Bhopal, you went here. I'll explain what is TXC. So from Delhi to Bhopal, you went here. So you are just dropping out some traffic out of like 40 events you are carrying. You want to drop 20 events over here. Okay, so this becomes the regenerator section because you cannot extract out straight away from STM1. You cannot straight away extract the events. You need to demultiplex it from the, as I explained in these slides. So this is the entire process gets repeated, and then you just get the one event from there. Okay, so like you are just dropping out signals over here, then others events, those events will also get regenerated in the form that you need not to have the sorry, you are regenerating the signal sort of, because you are converting it back to the even form and demultiplexing it, so it gets back converted into the even domain, and again gets multiplexed into the STM1. So that is why it is a regenerator section also, and it is a multiplex section also. Okay. Now, what is DXE? DXE stands for digital cross connect. So it is the whatever the cross connects you make in the SDH box, all are the at the digital level. In the PDH level, at the you make the cross connects at the electrical level. But when you make the cross connects at the STM level, at the optical level, it is called as a digital cross connect system. Okay, so now in this MUX section, this is like from Delhi to Bhopal, we came without any regenerator. Now from Bhopal, we have to go all the way to Chennai, which the distance is very long. So it may happen that just for this is a hypothetical network. This network will not be that big, but it's just a hypothetical situation. So from Bhopal to Chennai, okay. So you need to regenerate the signal at some location, which is a regenerator location. But here you are not adding or dropping anything. You are just performing the regeneration of the signal. You are just retiming the signal, reshaping the signal, and you are re-amplifying the signal. You just amplify the signal by increasing its power. So you are just regenerating the signal. You are not adding or dropping anything. So then this is called the regenerator section. Like suppose Raipur is there or Hyderabad is there. You just put one box over there, but you need not to drop any traffic from that box. So it is just regenerating the signal. So then it becomes the regenerator section. But from where you will start and you will drop the signal, it is called the like from Delhi to Chennai, you wanted to carry 40 events. Okay, you started with 40 events, you drop 20 events here, and you added 10 more events here at this location. So these 10 events, the multiplex section of those 10 events will be from here to here, or it will be the path for that event also. But for the event which started from here and terminated here, so this is the entire path of that event. So here the path overhead bytes come. And for the multiplex section, the multiplex section overhead bytes work. And for the regenerator section, only the regenerator section bytes work. So these are B1, B2, and B3 bytes, which I've shown here in the path and the regenerator in the multiplex. So B3, so these are BIP bits, which are there for the bit interleaving parity, checking the errors in the frame. So these are used for that purpose. If the error is from in the regenerator section, then it is being indicated by the B1 byte. If the error is in the multiplex section, then it will be checked by the B2 byte. And end-to-end path will have the B3 byte, which will check the error in the end-to-end path if it is there is an error. So if you get error in the B1 byte, that means the error is in this path. But if you get the error, if you see the error in the B2 byte, then the error is in multiplex section. And if you see the B3, then there is a problem at the entire path. So there are different bytes associated with the different section of the SDH frame.
Morning, sir.
So
Everybody here?
Yeah, please.
How do you signify a regenerator, sir, in what particular location that you can say a regeneration, whether it is in the STM level 1 or 4 or the 16 level, sir?
So it happens at each of the data rates. It can happen. So it all depends on your optics, how big your optics is. Like if you are putting the 20 kilometer SFPs, 20 kilometer, 40 kilometer SFPs, or 80 kilometer SFPs. So generally in SDH we have 80 kilometer SFPs, and we have some more SFPs that goes up to 120 kilometers. Okay, and if the distance is beyond that, then we need to regenerate the signal. Then there is one more option. We can put the amplifiers also. And we also, after by putting the amplifiers, it gives you the certain reach, certain extra reach, and it increases the power by a certain dB. And if beyond the amplifier, still the signal is not getting and your location is far enough, so then you need to add the regenerator in between. Suppose the distance 20 kilometer today, you just if your distance is increased and now you want to carry the signal further, you do not want to carry the signal at that location, you just change the SFP from 20 kilometer to 40 kilometer. You need not to add any regeneration. Now the distance again is moved up to 80 kilometer. You just change the SFP. You need not to have any regeneration. But after 80 kilometers, still you want to have carried further, then in some cases you have 120 kilometer SFPs. But in lower rates, the SFPs are very, it's not very workable solution. But then you need the amplifiers in the system. So what amplifier does is boost your trans power from the signal. And when it boosts the trans power, then you can further carry it from like 40-50 kilometers, like 160 kilometers, or maximum, if the very high power amplifier used, you carry it to up to 200 kilometers. So that is like rarest of rare case if you carry 200 kilometers. But beyond that, you need to have the regeneration point in between. So in the regeneration point, what you do, you just put one more mux over there, and you just regenerate the signal by using the another mux where the signal is regenerated. It is reshaped, retimed, and amplified. The signal is getting amplified, and then it is as good as a new signal from starting from this point, and it is carried forward to the end point. So this is the step-by-step the regeneration, how you can avoid the regeneration by changing the SFPs. And beyond SFPs, if it is still not happening, then you need to add the amplifier. And with the amplifier still it is not happening, then you need to regenerate the signal at some point. I hope this answers your question. So should I move ahead? So I'm getting some questions in the chat window. I'll take after the session those questions.
Sir.
Or you want me to just address it right now?
Sir.
Yes, please.
What is the basic difference between the regenerating muxes and the add drop muxes? Add drop muxes, there is questioning of adding and dropping events of various types. Right. Regenerations, there is nothing but amplification, de-amplification, or repeating of each and every event. So only difference is the add drop card will not be there. Just like the same type of STM.
Yes, in the region in regeneration, you regenerate the signal at the optical level. You do not go at the electrical level to regenerate the signal. So A1 is at the electrical level. At the optical level is the STM1 and STM4. You regenerate the entire signal for the STM1s and STM4. At that level, you regenerate the signal.
We will use the same type of STM, only provided with the system cards, no add drop card.
Your voice is not clear. What is it?
I am telling that in the regenerating muxes, there will be no add drop module. Add drop card will not be there, but only the system cards will be there. There is the power supply card.
The crossnet, yes, the crossnet card would be there where the regenerating signal will be happening. The STM or the STM4 ports you need to regenerate the signal, because signal coming from the behind, you need to put in some port, right? You need some port to regenerate the signal. So suppose if the STM4 is coming from the previous node, then at the regenerating node you put it in the STM4 port, and you just regenerate the signal and carry it out the signal from the another STM4 port. So at that point, the signal will be 3R functionality will happen. Okay, when we call it regenerate, the 3R functionality happen, which is like re-amplify, reshape, and retime. So what happens with the distance signals? The power gets distorted, the power gets less. So signal gets distorted with the lesser power. So the incoming mux is not able to comprehend the signal. So it regenerates the signal, it re-amplifies the signal, and then it reshapes and retimes the signal also. All the frame alignments and everything happens in the regeneration, and the frame is set as a new frame. It is as good as a new frame starting from the regenerating point. And then it is again carried forward for the whatever the kind of SFP you put. So it is again carried it forward like that only. I hope I answered your question, right? So
yes.
Okay, thank you. So I got some question from the chat window. I think I'll take this after the meeting. So let us. I hope this is okay, right? I'll just answer this one. What technology used for the submarine OFC regeneration of signal? So in the submarines, we use a technology called DWDM. Okay. So in DWDM, like in SDH, we have a frequency of 1310 nanometer or 1550 nanometer, on which this is working, SDH technology is working. This is a TDM based technology. Then there is a further step of it, what is called as a DWDM technology. So in the DWDM technology, we have wavelength multiplexing using the frequencies. So in that, so that is a FDM based technology, frequency division multiplexing, what we call. In that, different frequencies, like in SDH we have a 1310. In that we have a 1550 nanometer window where different frequencies are at a different frequencies at a certain distance, like they are 50 gigahertz apart or 0.4 nanometer apart. So it starts from 1528 nanometer, it goes up to 1565 nanometer, which what we call is C band, and every frequency, every channel is 0.4 nanometer apart. So we multiplex all those channels, which is about 80 channels, 80 10 gigs or 80 100 gig channels if we have. In that now we have 200 gig also. So in that we multiplex all those channels and carry it in the submarine. So it is the communication happens using the DWDM technology. So that itself is a it's a technology in it. So which is a further part of the SDH. So beyond SDH, what is beyond 10 gig and beyond 40 gig. So we use the DWDM technology to multiplex the larger bandwidths under the submarine, or even for the terrestrial network also we use the DWDM technology.
Sir, but
So
how much long distance it will carry signal?
In DWDM, it depends on the, because in DWDM there is a component called DSP, which is digital signal processor. In that 100 gigs, in the 100G channels, so it goes up to 2000 to 3000 kilometers without regenerating. So it all depends on the kind of DSP you use, the kind of fiber losses you use, the kind of launch power you're launching into the fiber. Then there's a whole technical word to it. But just to, as a thumb rule, we can go up to 2000 to 3000 kilometers for 100 without regenerating the signal. So now we have different modulations as a technology is advancing. We have even BPSK modulation working for the 100 gig channels with some vendors, with us also. So we go up under ideal fiber conditions, it goes beyond 5000 kilometers also without the regeneration of the signal. So if you talk about the summary, then you have the regeneration points and every 500 to 1000 kilometers at the landing stations are there. Like in India, it will start from the Chennai. So the landing station is at Chennai in Bombay, and from Chennai it goes up to the Singapore. Then we have an island in between where the landing stations are there, where the signal gets repeated. So engineering is done in such a way that signal reaches up to the regeneration point, and then again it will regenerate at that point, which is like 1000, 2000, 3000 kilometers away, and then it will get regenerated. So from Chennai to Singapore, it gets regenerated hardly at 1 or 2 landing stations. The signal reaches the Singapore. So from Bombay, it goes up to Europe. So then there are different landing stations in the Middle East. So just continuing with the discussion for this SDH, because it's a vast topic, it's a different topic in itself, the DWDM. Okay, so Railtel is using our DWDM, not Railways, but Railtel is using the Tejas DWDM. So data communication channel, what is the data communication? So by sitting at a central point, if you want to access the nodes, so how you can do that? You can do that by using the data communication channels, which is like D1 to D3 byte I told you in the RO switch, and D4 to D12. These 8 bytes are there, and there are 3 bytes in the regenerator section, and there are 8 bytes in the multiplex section. So these are the bytes inside the frames. So these bytes are used to communicate with the NMS. So whenever you communicate by using the NMS to the nodes, so these bytes comes into the picture. So these are used for various operations. So if you have a node in the NMS, then you can do all the operations in the node by using the NMS. You can monitor all the alarms. You can by sitting at a central place, you can know where is the fiber cut or how the fiber cut has happened, or the signal is down, the card temperature is high, the card is down, the signal is not there, the temperature is high. By sitting at a central location, you can do all these functions. So as good as you're sitting near the node and seeing what is happening. So then there is NMS, and then there are various functionalities attached to the NMS. Then you can get even the performance counters, like how the node behaved in last 1 day or in one month only last 15 minutes. So we have 15 minutes counters over there. We have 24-hour counters over there. So it depends whatever the kind of performance you choose. So it's tells
Sir,
you that
very low voice, sir. Very low voice. Not getting very low voice.
So just give me 5 seconds. I'll just change my headphone. Okay.
SSC लेवल में
Yeah, am I audible now? Hello, am I audible now?
जी जी
Okay.
जी बिल्कुल
क्लियर सर।
Okay. So मैं थोड़ा हिंदी में भी बोलता हूँ, मैं भूल गया था हिंदी वाली बात। सो D1 से D3 बाइट हैं, ये रीजनरेटर सेक्शन के लिए हैं। D4 टू D12 बाइट्स ये मल्टीप्लेक्स सेक्शन के लिए हैं। सो आप इनकी मदद से आप इसको एनएमएस के ऊपर नोड को मैनेज कर सकते हो। जब आप नोड को एनएमएस में मैनेज कर सकते हो, एनएमएस एक सर्वर है जिस पर कि हमने अपनी एप्लीकेशन डाली है तेजस की। सो आप एक सेंट्रल लोकेशन पर बैठ के आप दूर तक के भी नोड्स आप मैनेज कर सकते हो, और नोड्स के ऊपर जो भी हो रहा है वो आप देख सकते हो कि नोड का टेम्परेचर हाई हो गया है बिकॉज वहाँ का एसी बंद हो गया साइट का, या नोड के ऊपर कोई अलार्म आ रहा है, वहाँ पर एक्सटर्नल अलार्म्स भी आप कर सकते हो कैरी। तो बाय यूजिंग दिस एक्सटर्नल अलार्म्स कैसे होते हैं कि दरवाज़ा खुला रह गया, कोई मॉइस्चर ज़्यादा हो गया, मतलब बहुत तरह के अलार्म्स हो सकते हैं। वो 7 तरह के अलार्म्स आप कैरी कर सकते हो बाय डिफरेंट यूजिंग द डिफरेंट सेंसर्स। यू कैन एक्सटेंड द एक्सटर्नल अलार्म्स टू द फ्रॉम द साइट टू द एनएमएस। और एनएमएस क्या करता है, एनएमएस आपको अलार्म्स बताता है कि फाइबर कट हुआ तो कौन सा अलार्म आ रहा है, किस पोर्ट के ऊपर क्या अलार्म आ रहा है, उससे आपको पता चलता है कि कहाँ पर प्रॉब्लम हो गई है। नंबर 2, उससे आप परफॉर्मेंस मॉनिटर कर सकते हो। ठीक है, परफॉर्मेंस का मतलब क्या है कि आपका नोड ने पिछले 1 दिन में, पिछले 10 दिन में, पिछले 1 महीने में, 15 मिनट में, पिछले 24 घंटे में कैसे बिहेव किया। वहाँ पर डिफरेंट काउंटर्स हैं, अलग अलग काउंटर हैं। अगर उनकी वैल्यूज बढ़ी हुई है तो मतलब आपके नोड में एरर आई थी, तो आप उसको ट्रबल शूट कर सकते हो एरर्स को। आई थिंक सतीश विल कवर ऑल दिस पॉइंट्स कि वो कैसे आप ट्रबल शूट करते हो, कैसे पीएम काउंटर्स को एनेबल करते हो। सो सतीश विल कवर ऑल दोस पॉइंट्स। So the main function of DCC is for the management of the node. So अगर हम हर बाइट में जाएंगे तो इतना भी टाइम नहीं है हमारे पास, बट अगर मैं आपको मेन बाइट्स कवर कर रहा हूँ कि मेन बाइट्स नोड में क्या क्या बाइट की मदद से क्या क्या होता है। सो वट एवर इज हैपनिंग इन द SDH टेक्नोलॉजी, सो आई एम टेलिंग यू द मेन बाइट्स बिकॉज देयर आर मेनी बाइट्स इन द फ्रेम। इफ I'll talk about the frame, then itself it will take 2 hours to explain every byte. Okay. Then SDH में we have protections. Okay, so what if one side of the node goes down? अगर एक साइड से फाइबर कट जाता तो क्या होता, हम फिर प्रोटेक्शन डिफाइन करते हैं SDH में। सो हमारे पास 2 तरह की प्रोटेक्शन है। सो वी हैव 2 काइंड ऑफ प्रोटेक्शन, वन इज कॉल्ड MSP, another is SNCP, and another is MSSP ring. So MSSP ring I will not cover in this presentation because this is not the scope of the presentation. So I will cover only the MSP and SNCP, जो कि मैं हाई लेवल पे आपको बताऊंगा। मैं सिर्फ MSP और SNCP बताऊंगा, MSSP रिंग नहीं बताऊंगा बिकॉज अभी इसका वो पार्ट नहीं है इस सेशन का। अगर किसी को पूछना है वो मेरे से अलग से पूछ सकता है, मैं बता दूंगा। तो MSP क्या है? MSP आपका मल्टीप्ल सेक्शन प्रोटेक्शन है। सो इसमें आप क्या करते हैं, इसमें 2 पोर्ट्स को, सो आई विल बी इन वेरी लेमन लैंग्वेज, आई विल टेल यू। सो दिस MSP happens by using the K1 K2 bytes in the SDH frame. SDH frame के अंदर K1 K2 bytes होते हैं, उनकी मदद से हम इस प्रोटेक्शन को डिफाइन करते हैं। सो इसमें हम एक लिंक को हम वर्किंग बोल देते हैं और एक को हम प्रोटेक्शन इंटरफेस बोल देते हैं, विच इज 1+1। सो यहाँ पर क्या होता है कि 1+1 होता है और एक वर्किंग पाथ होता है, एक प्रोटेक्शन पाथ होता है। जैसे ही वर्किंग पाथ कटता है, so as soon as this working path gets cut, so K1 K2 bytes, by using the K1 K2 byte in the SDH frame, it will get switched to the protection type within 50 milliseconds. 50 मिलीसेकंड के अंदर ही ये वर्किंग पाथ से प्रोटेक्शन पाथ के ऊपर स्विच कर जाता है, जैसे कि उसको पता चलता है कि बाय यूजिंग K1 K2 बाइट की मदद से कि मेरा ये फाइबर कट गया है यहाँ पे उसको यहाँ पर LOS मिलता है, LOS सिग्नल रिसीव होता है और वो K1 K2 बाइट यूज करके प्रोटेक्शन पे यहाँ पे स्विच कर जाता है प्रोटेक्शन पाथ के ऊपर। और जो चूंकि स्विचिंग 50 मिली सेकेंड में हो रही है तो आपको कोई भी सिग्नल ड्रॉप नहीं होता है। सो सिंस द स्विचिंग इज हैपनिंग विद इन 50 मिली सेकेंड देन द नो सिग्नल गेट्स ड्रॉप। So if the switching is taking more than 50 millisecond, which is not the case, which is the ITU recommendation. So if the switching is happening more than 50 milliseconds, then you will observe the drop in the traffic for few seconds, for few milliseconds, not for seconds. So ये आपका point to point protection है MSP, ठीक है। अगर आपको रिंग में प्रोटेक्ट करना है, if you want to protect in the ring, then use the SNCP protection. So now this sub network connection protection, SNCP की फुल फॉर्म है सब नेटवर्क कनेक्शन प्रोटेक्शन। सो इसमें क्या होता है, ये एक पाथ प्रोटेक्शन है। सो यू प्रोटेक्ट होल पाथ बाय यूजिंग दिस होल रिंग बाय यूजिंग द SNCP प्रोटेक्शन एंड दिस प्रोटेक्शन डज नॉट डिपेंड ऑन द K1 K2 बाइट्स। ये जो आपका APS होता है K1 K2 बाइट्स उसके ऊपर डिपेंड नहीं करता है, ये डिपेंड करता है सिग्नल स्ट्रेंथ के ऊपर। अगर आपका सिग्नल स्ट्रेंथ अच्छा है तो ये वो वाला पाथ कैरी करता है, जिसका सिग्नल स्ट्रेंथ बेकार होता है तो उसको ये चूज नहीं करता है। सो इट वर्क इन दैट वे। सो इसमें आपका जो ट्रांसमिटिंग नोड होता है वहां पर दोनों तरफ से मेन और प्रोटेक्शन पाथ में दोनों से ही कनेक्टेड रहता है, जिसको हम बोलते हैं ब्रिजिंग मोड में रहता है वो। और जो आपकी स्विचिंग होती है वो आपकी रिसीवर एंड पे होती है। तो जो आपका रिसीविंग नोड होता है अगर उस पर कोई एरर आ रही है तो वो स्विच करता है, लेकिन जो ट्रांसमिटिंग एंड होता है दैट विल ऑलवेज बी कनेक्टेड, वो हमेशा कनेक्टेड रहेगा दोनों पाथ पे। बट स्विचिंग एक से होगा, स्विचिंग सिलेक्टिव होती है, स्विचिंग को सिलेक्ट करता है कि मेरे को किस पाथ से स्विचिंग को लेना है और किस पाथ से स्विचिंग को नहीं लेना है, किस पाथ से ट्रैफिक को लेना है किस पाथ से ट्रैफिक को नहीं लेना, वो स्विचिंग डिसाइड करता है। बट जैसे अभी हम बात करते हैं इसके अंदर कोई कोई जैसे इस ट्रैफिक को मान लीजिए दिस ट्रैफिक हैज टू गो फ्रॉम A to C, A to C से इस ट्रैफिक को जाना है, ठीक है। अब यहाँ पर फाइबर कट हो गया बिटवीन D एंड C, तो जैसे C को देखेगा कि फाइबर कट हो गया है वो अपने ट्रैफिक को यहाँ से उसको जब रिस्पेक्टिव अलाउंस मिलेंगे, LOS अलार्म मिलेगा और जो AI अलाउंस मिलेंगे हर नोड्स के ऊपर, जो वो मैं बताऊंगा कि कौन सी साइड में कौन सा अलार्म मिलता है। सो जो सिग्नल यहाँ से आ रहा था ओके वो वापस से दूसरे पाथ से होते हुए इस राउटर B से होते हुए यहाँ पर आ जाएगा और राउटर जो C वाला नोड है इसको सिग्नल मिल जाएगा। ये वर्किंग फाइबर था जो आप देख रहे हैं यहाँ पे। सिग्नल इससे नहीं मिला मुझे, सिग्नल इस वाले से मिला, प्रोटेक्शन वाले फाइबर से मिला मुझे सिग्नल। ये SNCP प्रोटेक्शन है। सो इसमें क्या होता है कि इसमें बाय यूजिंग द BER एक वैल्यू होती है बिट एरर रेशियो, तो जिस भी पाथ का बिट एरर रेशियो बेटर होता है, सो आउट ऑफ टू पाथ्स, so whatever path is having the better bit error ratio, the BER value, so it selects that path as the working path and other path is as the protection path. So जैसे ये मेरा फाइबर रिस्टोर हो जाता है, as soon as this fiber gets restored, so there is an option called revertive and non-revertive in that. अगर आपने revertive select किया है, if you selected revertive, then it will revert back to the original path. Otherwise, it will not get revert to the original path. It will stay at the protection path. सो अगर आपने रिवर्टिव सेलेक्ट किया है तो ये प्रोटेक्शन पाथ पे नहीं रहेगा, प्रोटेक्शन पाथ से ये मेन पाथ के ऊपर स्विच कर जाएगा। अगर आपने नॉन रिवर्टिव सेलेक्ट किया तो ये फाइबर रिस्टोर भी हो जाएगा तो भी कोई फर्क नहीं पड़ेगा, प्रोटेक्शन पाथ पे चलता रहेगा। सो दिस इज द मेन प्रोटेक्शन टाइप्स। सो देन देयर इज अनदर प्रोटेक्शन टाइप कॉल्ड MSSP रिंग which is not the scope of the discussion. If anyone wants to discuss it then I can take it offline. But since I have to cover mainly the product also, so I'll just quickly moving into the product from the technology. So hope this is clear to you and we can move to the product part of it. So we have various ranges of product for the SDH also for the DWDM, but what we will discuss in this session is the 1407 जो कि आप लोग हमसे लेते हैं, हम सिर्फ उसी प्रोडक्ट की भी बात करेंगे। So 1407 में क्या, 4707 is a 2 RU चेसिस, ये 2 RU के चेसिस है। इसके अंदर दो तरह के स्लॉट होते हैं, एक होते हैं एग्रीगेट स्लॉट और एक होते हैं ट्रिप स्लॉट। सो एग्रीगेट स्लॉट क्या करते हैं, सारे ट्रिप स्लॉट्स का ट्रैफिक एग्रीगेट करके उन सबको इकट्ठा करके एग्रीगेट पोर्ट से बाहर ले जाते हैं और अपना यहाँ तो फिर एग्रीगेट पोर्ट का खुद का कोई ट्रैफिक होगा तो आप उसके ऊपर भी डायरेक्टली उसको कैरी कर सकते हो। सो इन दिस बॉक्स वी हैव 7 स्लॉट्स, 5 ट्रिप कार्ड्स हैं आपके और 5 ट्रिप स्लॉट्स हैं और 2 आपके क्रॉसनेट कार्ड्स हैं। सो इसकी मैं आपको दिखाता हूँ। सो ये बॉक्स आपका ऐसे दिखता है अगर आप देखेंगे तो। जो ये ब्लू वाला है इसमें अलग अलग तरह के क्रॉसनेट कार्ड्स हैं। डिपेंडिंग ऑन योर रिक्वायरमेंट देयर आर डिफरेंट क्रॉसनेट कार्ड्स इन द ब्लू कलर। और जो ये ऑरेंज वाले हैं ये 5 आपके ट्रिप स्लॉट्स हैं। अगर आपको E1 की रिक्वायरमेंट है 63 E1 का आप जैसे कार्ड डालते हैं, या आप E3 की कार्ड रिक्वायरमेंट है, या आपको STM 1416 अलग से चाहिए जो कि क्रॉसनेट कार्ड से ज़्यादा पोर्ट्स चाहिए, अब वो कार्ड T18। तो ये सब ट्रिप स्लॉट्स में जाते हैं। ये सारे ट्रिप स्लॉट्स कनेक्ट होकर एग्रीगेट स्लॉट से आप आउटपुट लेते हो। आप ट्रिप टू ट्रिप भी ले सकते हो, बट आप मेनली इन ट्रिप स्लॉट्स को एग्रीगेट करके आप एग्रीगेट स्लॉट्स के आउटपुट लेके दूसरी जगह पे लेके जाते हो। इसमें रिडंडेंट पावर यूनिट्स भी हैं। रिडंडेंट अगर आपका पावर फेलियर हो गया, एक कार्ड अगर खराब हो गया तो दूसरा कार्ड उसको टेक ओवर कर लेगा। और इसमें फैंट्री यूनिट है राइट हैंड साइड में, लेफ्ट हैंड साइड में एयर फिल्टर है। सो द फ्लो इज फ्रॉम लेफ्ट टू राइट। सो यहाँ पर जो फैन लगा है वो हवा अंदर खींचता है, ये एयर फिल्टर उसको फिल्टर कर देता है और इन कार्ड्स को ठंडा रखता है, कूल रखता है। सो दिस इज द लेआउट ऑफ द 1407 शेल विच इज ए 2RU शेल। अब इसमें हम कार्ड्स कौन कौन से यूज करते हैं? सो वी हैव a very vast range of the cards, but in this session we will cover.
Sir, actually, why it was called as power filter unit. Power filter unit means power unit, no? Yes, power filter unit.
So it is called. So this is basically power cards ही होते हैं। I need to get back to you why it is called
क्या
filter unit.
चीज को फिल्टर करता है? उसमें फिल्टरिंग का है क्या सर? कोई रिपल फिल्टरिंग होता है ऐसा कुछ है क्या?
ये मुझे चेक करना पड़ेगा, मुझे इसमें आइडिया नहीं कि फिल्टर क्यों होता है, ये मेरे को इंजीनियरिंग से चेक करना पड़ेगा फिल्टर क्या होता है। सतीश, इफ यू कैन ऐड समथिंग टू इट। बट एयर फिल्टर आपका डस्ट को रोकता है, दैट इज फॉर श्योर। और जो पावर फिल्टर यूनिट है ये आपके पावर कार्ड्स हैं जिससे कि आपको शेल्फ को पावर मिलता है। बट इसमें फिल्टर क्या हो रहा है, आई नीड टू चेक इट। सतीश, यू हैव एनी आइडिया अबाउट दिस?
No, basically it is power supply unit. Maybe some typo error.
Okay.
We call it as PSU, power supply unit.
Maybe
फिल्टरिंग हो सकता है जो कोई अगर रिपल डिस्टरबेंस होगा उसको फिल्टर कर रहा है या नहीं, ऐसा ही सोच रहा है।
नहीं सर, उसका पावर सप्लाई कार्ड का नाम ही जैसे आप देखेंगे तो DPU 8 होता है, इस तरीके से है। तो DC पावर सप्लाई यूनिट जो है तो मे बी टाइपिंग एरर, टाइपिंग।
आई एम टेलिंग सर रिपल्स पावर में कभी कभी कुछ सोचिए हमारा चार्जर ऑन कंडीशन में बैटरी से पावर आ रहा है तो उसमें चार्जर के लिए कुछ रिपल्स आ सकता है, तो ऐसा ना हो जो ये रिपल को भी फिल्टर कर देता है ऐसा।
रिपल फिल्टर नहीं सर, इसमें कार्ड में जो है फ्यूज रहते हैं तो वो कुछ यूनिट्स तक जो है उसका रेंज है -42 टू -54 तक है। तो वो आप उस यूनिट उसमें तो अगर रिपल्स आएंगे तो उतना वो कैटर कर लेगा।
ओके सर, ठीक
है सर।
So we will get it clarified कि it is why the filter is there or it is just a typo. We'll get it clarified. Mohit, हम इसको we'll get back to you on this.
Okay, no issue. I can note it.
Okay. So then aggregate cards कौन से हैं? वैसे तो we have a very vast range of aggregate cards, but हम इसमें जो scope में जो railways हमसे procure करते हैं उसी की बात करेंगे। So first called is card XA14ET, which is 2.5 gig cards. So it is having. Sorry. So it is having 2 STM1 ports or 1 STM4 ports, and it is having 32 evens. Then there is a higher version of card which is called XA14OT5. You use this card for the STM4. So it is having 2 STM4 ports and 2 STM1 ports also, but it is not having any even port. Then there is a higher variant of it which is called XA10G, which is a crossnet size is now updated to 15G. It is an old 10G written over here. So it is now 15G. In this we have 1 STM4 and 1 STM16, and then we get additionally we get 2 STM1s also. Then if it is a hub location at the aggregate location, we need XS60G, which is a 60 gig crossnet card. It is one STM4 port, STM64 ports, which is a 10 gig port, and then it has a couple of STM1 and 4 ports and 2 STM4 and 16 ports. So these are the different aggregate cards what we are using in the railway. Trip cards कौन से हैं? So what are the trip cards what we use? So we have a one card called SOT18. So it is a 8-port STM1 card. Okay, इसमें 8 port होते हैं, total 8 physical ports are there. Now you can use these 8 ports as the 8 STM1, or you can get 2 STM4s. अगर आप 2 STM4 लेते हो तो 6 पोर्ट पे कुछ नहीं ले सकोगे, और आप नहीं तो एक STM16 भी ले सकते हो. सो ये डिफरेंट मोड्स हैं जिसमें कि आप इस कार्ड को यूज करते हो. 4 STM1 ले लिया आपने, 4 STM1 ले लिया और एक STM4 ले लिया, तो बाकी 3 पोर्ट यूज नहीं होंगे. या फिर एक STM4 ले लिया और 4 STM1 ले लिए. ऐसे करके आप इस पोर्ट्स को कार्ड को डिफरेंट मोड्स में यूज कर सकते हो डिपेंडिंग ऑन योर रिक्वायरमेंट. देन वी हैव ST63 even कार्ड. इट इज अ 63 even कार्ड. अगर आपको even कार्ड चाहिए, 63 even चाहिए, तो आप ये कार्ड लेते हो. इस कार्ड में 32 इवन्स के 2 कनेक्टर होते हैं. तो अगर आप देखेंगे हमारी जो केबल आती है, इवन केबल व्हाट वी सप्लाई इज फॉर 32 इवन केबल. So that is precisely the reason why it is 32 dB, because the connector is such that it supplies only up to the 32 evens. So you connect two such cables in the card and you get 63 evens. Then we have ST6E3 card. So जो ST6E3 card है, इसके अंदर 6 आप 6 E3 और DS3 चैनल्स आप टर्मिनेट कर सकते हो. These are BNC type connectors. So E3 और DS3 क्या होता है? It is a 34 Mbps signal and DS3 is 44 Mbps signal. So DS3 जो मैंने आपको बताया था कि अमेरिकन स्टैंडर्ड है, यूरोपियन स्टैंडर्ड है. सो अमेरिकन फॉलो करते हैं DS एंड यूरोपियंस और इंडियंस फॉलो करते हैं यूरोपियन स्टैंडर्ड which we call as E3. So 34 Mbps सिग्नल जो होता है उसको हम इस सिग्नल के जैसे E1 एक इंटरफेस है, ऐसे ही E3 और DS3 भी एक इंटरफेस टाइप है. इसका डेटा रेट था 34 Mbps. इसमें 21 इवन्स आते हैं. जो मैंने आपको एक टग 2 दिखाया था, तो एक सिंगल टग 2 एक E3 में होता है, तो 3 E3s मिलके एक STM1 बनाते हैं. तो इसमें आपको अगर इवन आपको E3 टर्मिनेट करना तो आपको ये कार्ड देना पड़ेगा जिसमें कि 6 पोर्ट है. 12 पोर्ट टोटल ट्रांस रिसीव के मिला के 12 पोर्ट है, बट सिंगल सिग्नल के लिए 6 पोर्ट है.
SOT18 में अगर STM4 का SFP मॉड्यूल लगा दिया है आप,
राइट,
तो जो लिंक है STM4 की हो जाएगी ना?
नहीं STM4 ही रहेगा.
और हमको जैसे कहीं ब्रांचिंग स्टेशन पे लगाना है और एक SOT18 ब्रांच लाइन पे ले जा रहे हैं और SFP4 का मॉड्यूल लगा दिया, तो STM4 की लिंक हो जाएगी ना?
आपकी आवाज क्लियर नहीं आ रही, एक बार दोबारा बोलेंगे?
SOT18 कार्ड जो है अब लगाना किसी स्टेशन पे जहाँ ब्रांचिंग स्टेशन है हमारा, जहाँ 3 लाइन जा रही है, वहाँ लगाया है, वहाँ STM4 मॉड्यूल लगा दिया मैंने. तो STM4 की लिंक हो जाएगी आगे जो जाने वाले.
हाँ, राइट आप STM4 को लिंक ले सकते हो उससे.
सर एक बार SOT18 बोलिए ना सर. SOT18 एक बार प्लीज बोलिए.
ओके, सो SOT18 के अंदर 8 पोर्ट है टोटल. फिजिकली 8 पोर्ट आपको दिखते हैं. अगर आपको STM1 लेना है तो आप हर पोर्ट से STM1 ले सकते हैं, जिससे कि आपको 8 STM1 मिल जाएंगे. सपोज अगर आपको रिक्वायरमेंट STM4 का, जैसे घनश्याम जी ने बताया, तो अगर आप किसी एक पोर्ट में STM1 डाल देते हो, इसमें 2 ग्रुप है, P1 से P4, P5 से P8. अगर आप P1 से P4 में एक STM4 का SFP डाल देते हो, तो बाकी 3 पोर्ट आप यूज नहीं कर सकते. फिर आप P5 से P8 के अंदर आप STM1 ले सकते हो, तो आपको एक STM4 मिल गया, 4 STM1 मिल गए, या वाइस वर्सा. या आपने P5 में STM4 डाला तो 6, 7, 8 आप यूज नहीं कर सकते. P1 से P4 आप STM1 के लिए यूज कर सकते हो.
ये कनेक्टर क्या सर FCLC टाइप कनेक्टर है सर? ये जो चौका जो कनेक्टर सर दिखाई दे रहा है,
ये कनेक्टर नहीं, डायरेक्टली इसके अंदर SFP जाता है, और SFP का कनेक्टर होगा LC कनेक्टर.
मतलब फाइबर कनेक्शन होता है FC
इसके अंदर नहीं होगा. LC राइट. दूसरे एंड पे क्या हो गया तो आपका FMS डिसाइड करेगा, बट हमारे कार्ड के ऊपर LC है.
राइट.
तो इसके अंदर SFP जाता है, ये इसके अंदर एक और प्लगेबल यूनिट जाती है, फिर आप उसके ऊपर फाइबर कनेक्ट करते हैं. तो आप इस कार्ड से या तो फिर 2 STM4 ले सकते हो, 8 STM1 ले सकते हो, या फिर अगर आपको STM16 भी चाहिए तो आप एक STM16 ले लो, तो आपको बाकी सारे पोर्ट्स यूज नहीं होंगे। वो पोर्ट्स एक पोर्ट पे STM16 मतलब दिखना पड़ेगा कौन सा पोर्ट नंबर है, तो उसके ऊपर अगर आप डाल दोगे तो बाकी पोर्ट्स आप यूज नहीं कर सकोगे।
सर STM4 2 यूज करना है तो एक पहले स्लॉट में लगाते हैं, एक कौन से 5 में लगाना पड़ेगा,
राइट
है ना?
सर एक क्वेश्चन है सर कार्ड से रिलेटेड।
हाँ जी, हाँ जी।
एक सर एक क्वेश्चन है कि जो आपने बताया कि XA14ET कार्ड उससे हम 32 E1 लेते हैं, यदि हमको 32 से ज्यादा E1 की जरूरत है तो उसके जगह पे XA14ET कार्ड के जगह पे कौन सा कार्ड यूज करेंगे सर?
सर अगर आपको 32 से ज्यादा E1 चाहिए तो आपका ये 63 E1 का कार्ड है, ये आपका ट्रिप स्लॉट में जाता है।
नाम
तो
क्या है सर उसका?
ST63 E1, ये मैं आपको दिखा के ऊपर अगर आप देखेंगे तो ये 32 और 32 E1 के 2 कनेक्टर और हैं इसमें, तो आपको 63 E1 मिल जाते हैं। अगर आपको 63 से भी ज्यादा चाहिए तो 2 ऐसे कार्ड लगा लीजिए, टोटल आप 5 ऐसे कार्ड लगा सकते हैं एक चेसिस के
तो
अंदर।
मतलब ये कार्ड XA14ET मतलब 63 कार्ड का नाम है सर?
ST63 इसका कार्ड नेम, कार्ड का नाम है ST63 E1। अगर आप देख रहे हो मेरा पॉइंटर जो दिख रहा है तो आपका ये कार्ड का नाम है ST63 E1।
अच्छा, XT63 E1 कार्ड। तो इसमें सर वो LFH कनेक्टर सर 32 का आता है या फिर एक ही LFH कनेक्टर में ये 63 E1 मिलेगा हमको?
नहीं, ये कार्ड के अंदर तो 63 E1 होंगे, बट आपको केबल 2 लगानी पड़ेगी, E1 केबल 2 लगानी पड़ेगी। जैसे आप देख रहे हो ना यहाँ पे कि 2 अलग अलग पोर्ट हैं, तो आप एक ही केबल लगाओगे तो उससे 32 E1 मिलेंगे, दूसरी केबल लगाओगे तो उससे बाकी के 32 E1 मिलेंगे, तो टोटल आपको 63 E1 मिल जाएंगे।
तो 32 तो सर 64 हो
नहीं,
गया।
मतलब 32 और 31 63 E1 से ये नंबर भी लिखा हुआ है, 1 से 32 यहाँ मिलेंगे और 63 से 33 से 63 नंबर E1 जो होंगे वो आपको यहाँ से मिलेंगे।
तो मतलब उसी मतलब 2 LFH कनेक्टर लगाना पड़ेगा।
राइट, तो लगाना पड़ेगा
सर इसका
32 का।
इसका सर पेलोड कैपेसिटी जो है सर वो जस्ट STM1 का ही है, इसका मतलब 63 E1
हाँ जी, हाँ जी, हाँ जी, हाँ जी, 63 E1 का मतलब STM1 पेलोड है टोटल।
STM1 ही है उसका पेलोड कैपेबिलिटी।
हाँ जी, हाँ जी, अगर आप STM1 का कैपेबिलिटी देखोगे, STM1 का डेटा रेट है 155 Mbps का और एक E1 होता है 2 Mbps का। तो जब आप 63 E1 से 63 से मल्टीप्लाई करोगे तो वो आएगा 129 Mbps। ठीक है, उसके अंदर पेलोड कैपेसिटी 129 Mbps हो गया। फिर STM फ्रेम के ओवरहेड बाइट्स ऐड होंगे, जो कि मैंने आपको दिखाया था ओवरहेड बाइट्स, वो ऐड होगा, वो 155 Mbps
होगा, पॉइंटर भी ऐड होगा, ऐसा होके सर अल्टीमेटली 155.52
बन जाएगा। राइट,
बन जाएगा। लेकिन सर सोचिए हमारा STM4 के लिए तो ऐसा हमारा 4 वो चाहिए ना।
STM4 के लिए आपको 622 Mbps हो जाएगा, उसके अंदर आप 252 E1 कैरी कर सकते हो।
सर ऐसे ही 4 को आइडेंटिकल होगा तब उसमें
ऐसे 4 कार्ड आइडेंटिकल होंगे। राइट, अगर आप ऐसे 4 कार्ड लगाते हो तो आप चारों को एक ही STM4 से आउट कर सकते हो, उसका टोटल कैपेसिटी 622 Mbps होगा। तो 252 E1 है, अगर आप उसको 2.2.048 से मल्टीप्लाई करोगे और फिर आप उसमें ओवरहेड बाइट्स ऐड करोगे तो आपको वो 622 Mbps का STM4 फ्रेम बन के निकलता हो।
हाँ सर, हाँ सर, ठीक।
अभी आ जाते हैं ईथरनेट कार्ड के ऊपर। तो जो मेनली ईथरनेट कार्ड आप लोग देखते हैं, सो वट एवर यू बाय इस लार्ज नंबर इज सेल 1 कार्ड। इस सेल 1 कार्ड में क्या है, इसमें 2 गीगी पोर्ट्स हैं, 1 गीगी इलेक्ट्रिकल पोर्ट है और 3 FE हैं। अगर आपको 4 FE चाहिए होते हो तो आप इस गीगी पोर्ट को भी FE पोर्ट बना सकते हो, क्योंकि यहाँ पर 10/100/1000 लिखा हुआ है और ये 10/100 है। सो आपको 4 FE मिल जाते हैं और 2 गीगी मिल जाते हैं, या फिर आप 3 गीगी ले सकते हो और 3 FE ले सकते हो। सो ये L1 कार्ड है, इसके अंदर आपको जंबो फ्रेम का सपोर्ट है अप टू 90 to 60 बाइट। तो इथरनेट के अंदर बहुत बार जंबो फ्रेम्स आते हैं, शायद आप लोगों को, मेरे को नहीं लगता यूज होता होंगे, तो वो सपोर्ट भी अवेलेबल है। और इसके अंदर हम VCG मैपिंग करते हैं। जब आप कनेक्ट करते हो तो हर इथरनेट आपका कैरी कैसे करता है SDH के अंदर। सो एक टेक्निक है, उसका नाम है EOS, इथरनेट ओवर SDH। सो इथरनेट फ्रेम को हम बाय यूजिंग द GFP फ्रेम, एक अलग पूरा टॉपिक है। सो उसको हम एनकैप्सुलेट कर लेते हैं और उसको हम इथरनेट ओवर SDH के फॉर्म में कैरी करते हैं, या फिर हम उनको VCGs फॉर्म में कैरी करते हैं, जिसको हम बोलते हैं वर्चुअल कंकैटिनेटेड ग्रुप। ओके, अब क्या होता है कि जैसे आपका मान लो 20 Mbps का ट्रैफिक है, आपका 20 Mbps ट्रैफिक आपने इस एफई पोर्ट में दे दिया, अब आप उसको कैरी कैसे करोगे STM1 के ऊपर। सो 20 जो Mbps होगा उसके कितना इवन लेवल पे बनेगा, कितने उसके एक STM1 के अंदर 63 इवन आ सकते हैं। मैं एक बहुत लेमन में बता रहा हूँ, ऑल्दो द टर्मिनोलॉजीज आर डिफरेंट, बट मैं एक लेमन में बता रहा हूँ आपको। तो आप उसको उसके VC12 आप कितने मैप कर सकते हो, इवन को VC12 भी बोलते हैं। तो जैसे 20 Mbps आया तो वो टोटल 10 Mbps सॉरी 10 VC12 हो गए। सो इन वन VCG we will connect 10 VC12 to carry that 20 Mbps। तो एक वो VCG बन जाएगा और VCG जाकर आपका एक STM1 से कनेक्ट हो जाएगा और STM1 इसको कैरी करेगा, एंड एट द अदर एंड दूसरे एंड के ऊपर आप उसको VCG को वापस VC12 से कनेक्ट करके और उसे आप इथरनेट में कन्वर्ट करके वापस आप उससे 20 Mbps निकाल लोगे। सो इसका फायदा ये होता है कि आप कितने भी आप VCG जितने भी आपकी बैंडविड्थ रिक्वायरमेंट है आप उतने ही VCGs आप कनेक्ट करो, आप कोई बैंडविड्थ वेस्ट नहीं कर रही है यहाँ पे। अगर आपको 40 Mbps है तो उसमें और VCGs ऐड कर दो। सो एक और टर्मिनोलॉजी इसके अंदर होती है LCAS, लिंक कैपेसिटी एडजस्टमेंट्स की। सो उसके अंदर आपको जितने भी VCGs के अंदर VC12 ऐड करने हैं या रिमूव करने हैं, यू कैन ऐड और रिमूव दोस VCGs by using that LCAS since it will be a hitless addition and deletion from that VCG. So you can add or you can delete some VCs from that VCG to increase or to reduce the bandwidth, and it will be hitless addition and deletion. Traffic will not get down, either it will get truncated or it will get expanded just by using the LCAS functionality. So कई बार आपको L2 Ethernet की रिक्वायरमेंट होती है, so उसके लिए हम CEF1 कार्ड यूज करते हैं, which is a carrier Ethernet कार्ड। इसमें 2 गिगी पोर्ट होते हैं, P5 और P6। P1 से P4 जो है वो आपके FE पोर्ट होते हैं, और जो P3 और P4 है आप इसको एज ए इलेक्ट्रिकल गिगी भी यूज कर सकते हो, बट सिंप्लिसिटी के लिए आप P1 से P4 FE मानिए और P5 से P6 को गिगी मानिए। सो अगर आपको L2 की रिक्वायरमेंट है जहाँ पर आपको VLANs वगैरह कॉन्फ़िगर करने हैं तो आप CEF1 कार्ड को कैरी करते हो, CEF1 कार्ड लगाते हो। एक और वेरिएंट है हमारे पास CEF190। अगर आपकी नंबर ऑफ पोर्ट्स आपको ज़्यादा चाहिए, इस कार्ड के अंदर 9 पोर्ट्स हैं टोटल। तो 9 पोर्ट में से 3 पोर्ट हैं वो तो कॉपर पोर्ट्स हैं जिसके अंदर कि आपको गिगी भी मिल जाता है, और 5 पोर्ट जो हैं वो आपके गिगी पोर्ट्स हैं। सो ये टोटल 9 पोर्ट का कार्ड है। ये आपके रेलटेल में भी लगा हुआ है, रेलवेज में काफ़ी कम जगह सप्लाई किया हुआ है, बट किया हुआ है। सो इसके अंदर जैसे कि मैंने आपको LCAS बताया था, हिटलेस एडिशन और डिलीशन ऑफ अ बैंडविड्थ विद इन ए VCG। अगर आपको VCG के अंदर बैंडविड्थ ऐड और डिलीट करनी है तो आप LCAS फंक्शनलिटी यूज कर सकते हो, वो भी अवेलेबल है CEF190 कार्ड के अंदर। और जंबो फ्रेम सपोर्ट भी है, जिसमें कि आपको अगर फ्रेम साइज बड़ा होता है इथरनेट, तो फ्रेम साइज 1500 बाइट 64 बाइट से 1500 बाइट्स तक होता है। बट अगर आपके बड़े फ्रेम साइज आ रहे हैं पीछे से ही, अगर आपको जंबो फ्रेम सपोर्ट चाहिए तो दैट इज आल्सो अवेलेबल इन CEF190। सो देन देयर इज अनदर कार्ड कॉल्ड CEF4 कार्ड। ये हमारा एक L2 कार्ड है। अगर आपको मान लो MPLS TP पे अपग्रेड करना है अपने SDH बॉक्स को, ओके, तो आप वो स्ट्रेट अवे कर सकते हो। आपको उसके लिए हार्डवेयर चेंज करने की जरूरत नहीं है, आपका 1407 शेयर वैसी लगी रहेगी। MPLS TP एक टेक्नोलॉजी है जहाँ पर कि अगर आपको बैंडविड्थ के अंदर स्टैटिकल मल्टीप्लेक्सिंग चाहिए, या आपको डिफरेंट बैंडविड्थ चाहिए कि मेरे को ये बैंडविड्थ मुझे इंटरनेट के लिए देनी है, ये बैंडविड्थ मुझे फोन्स को देनी है, ये बैंडविड्थ मुझे एक डेडिकेटेड बैंडविड्थ चाहिए, मुझे डेडिकेटेड गारंटेड बैंडविड्थ चाहिए, यहाँ पर मैं बैंडविड्थ अप डाउन कर सकता हूँ। सो उसके अंदर एक टेक्नोलॉजी होती है MPLS TP। सो बाय यूजिंग दैट टेक्नोलॉजी, जहाँ पर कि आप अपनी बैंडविड्थ को कई गुना बढ़ा सकते हो। अगर आपको 10 गिग चाहिए तो आप उसके अंदर 20 गिग का ट्रैफिक डाल सकते हो, क्योंकि आपका उसमें जो बाकी 10 गिग ट्रैफिक होगा वो हर टाइम यूज नहीं हो रहा होगा, वो कुछ टाइम यूज हो रहा होगा, कुछ टाइम जैसे इंटरनेट का ट्रैफिक है, आप इंटरनेट का ट्रैफिक कभी यूज करते हो कभी नहीं करते हो, तो उसको हम स्टैटिकल मल्टीप्लेक्सिंग बोलते हैं। तो स्टैटिकल मल्टीप्लेक्सिंग आप MPLS TP में कर सकते हो। सो बाय यूजिंग दिस CEF4 कार्ड आप MPLS TP पे अपने बॉक्स को अपग्रेड कर सकते हो। इसके अंदर 2 10 गिगी के पोर्ट्स हैं और 2 गिगी पोर्ट्स हैं। सो उसमें जब हम STM1416 कैरी करते हैं फाइबर के ऊपर, इसमें हम फाइबर के ऊपर 10 गिगी कैरी करते हैं, विच इज गीगाबिट ईथरनेट। तो हम फाइबर के ऊपर ईथरनेट कैरी करते हैं, हम एसटीएम्स कैरी नहीं करते हैं एमपीएस-टीपी के अंदर। सो इसकी जो स्विचिंग कैपेसिटी दैट इज 64 जीबीपीएस, और मतलब एक पूरी अलग तरह से टेक्नोलॉजी है, तो उसको हम इस सेशन में कवर नहीं कर रहे हैं। बट मैं आपको एक ओवरव्यू देना चाह रहा था कि SEF4 कार्ड की मदद से वी कैन अपग्रेड द सेम बॉक्स फ्रॉम SDH to the MPLS-TP, which is an upgraded version of the SDH के से the next technology है layer 2 technology MPLS-TP, हम उस पे अपग्रेड कर सकते हैं उसको without changing the hardware. So that's it from my side. Although the scope is very big, we could have covered more topics into it, but I just tried to limit it according to the time. तो अगर if you have any questions, अगर आपके questions है तो प्लीज पूछें, नहीं तो फिर सतीश को मैं हैंड ओवर करता हूँ फॉर द ट्रबल शूटिंग ऑफ द इक्विपमेंट कैसे करते हैं। So I'm getting some
Sir,
questions in
minute,
the
excuse me.
yes yes please.
एक क्वेश्चन है, starting station I have a 10 Mbps bandwidth and I have to drop at 5 station to 2 Mbps. So how will I drop? Shall I have to make different cross connect VCGs for each station, or can I use the same port?
So then there are two ways to do it. Yes, you can make the different VCGs for each EV, each of the station. You can do it. और अगर आपका L2 नेटवर्क है, अगर आपका L2 इथरनेट अगर आप यूज करना चाहते हैं तो L2 इथरनेट को यूज करके भी आप कर सकते हैं, बट फॉर द सिंप्लिसिटी पर्पस आप डिफरेंट VCGs बनाइए और डिफरेंट VCGs को डिफरेंट स्टेशन पे ड्रॉप करते जाइए अकॉर्डिंग टू रिक्वायरमेंट, तो आपको उसके हिसाब से आप बैंडविड्थ उसको ड्रॉप करते जाइए। बट इसमें क्वेश्चन आता है कि आप डिफरेंट स्टेशन
पॉसिबल ना?
सॉरी, यस इट इज वेरी मच पॉसिबल, वेरी मच पॉसिबल। आप लोग करते भी हैं सर। सो चैट बॉक्स में कुछ क्वेश्चन है, मैं उसको ले लेता हूँ। व्हाट इज द डिफरेंस बिटवीन, रिवर्स से स्टार्ट कर रहा हूँ। Sometimes EMS access can't get after restart equipment, only if it will get access. Please clarify. So ये Satish will carry this. Satish, so take this question that sometimes EMS access not getting after restart equipment, only it will getting access. So Satish will take this question. EMS का नहीं आता। What is the difference between Cell1 and SF1? Cell1 और SF1 में Cell1 आपका L1 Ethernet कार्ड है, SF1 आपका L2 Ethernet कार्ड है। So L1 और L2 में डिफरेंस क्या है कि L1 Ethernet एक प्लेन Ethernet है, पीछे से Ethernet आया and we carried over that Ethernet from the Ethernet card and just dropped it at the another location. SF1 के अंदर हम L2 Ethernet यूज करते हैं, जिसके अंदर की हमारी VLAN फंक्शनलिटीज भी होती है, हमें VLAN टैगिंग भी हम उसको कर सकते हैं उस ट्रैफिक को, to identify the traffic type. So we can use that by using the SF1 card. So Cell1 is a L1 Ethernet and SF1 is a L2 Ethernet card. What is the technology used for submarine OFC for regeneration of signal? I've already answered. How much longest distance we can transfer optical signal without using STM? So without using STM, I guess the distance cannot be traveled much. It will be in terms of meters only if you're talking about events, because so then when the electrical signal gets, they cannot travel much. And in the STMs we have a light operating over there, so उसमें हम different distances जा सकते हैं, but if it is an electrical distance, it will be in the meters. So that depends on the kind of interface you're using. Another question is why we combine 3 TU12 to make one TUG2? Why not 4 TU? What is the logic behind that? Okay, so the logic behind them is कि हमारा STM का frame structure है. Okay, so that structure is defined like this. If we'll have the 4 TUs, okay, so then the whole structure will be disturbed and we can मैंने जैसे आपको multiplexing दिखाया था, so I'll just go back to that slide. So this is a standard what everyone has to follow. Whoever is not following it will not be SDH vendor, or he'll be locking his text according to this. So then there is a standard which was defined by ITOT कि हर किसी को 3 TU12 ही देने, and then when you take 3 TU12s and then according to the TUG2 and TUG3, because इसके अंदर बहुत सारे आपके और भी pointers added होते हैं, और इसके अंदर फिर आपकी बिट जो बिट बाइट्स होती है उनके एडजस्टमेंट पॉइंटर्स भी होते हैं, इसके अंदर की हम स्टफिंग भी बोलते हैं उसको, पॉजिटिव स्टफिंग, नेगेटिव स्टफिंग। एंड देन उसके अंदर वो सिंक्रोनाइजेशन जो होता है नेटवर्क का, वो उसके बेस के ऊपर ही जो स्टफिंग्स कर रहे हैं उसके बेस के ऊपर, जस्टिफिकेशन बाइट्स के बेस के ऊपर ही आपका नेटवर्क के अंदर जो सिस्टम फ्रेम बनता है उसी के बेस पे बनता है। सो एवरीवन हैज टू फॉलो द स्टैंडर्ड्स। So why the standard is there? Probably the standard is there because they might have thought about the different rates, how the different rates needs to be transferred. So based on that, and what is the standard that needs to be followed, so next standard का adopt किया. So this is the उसके because इसके अंदर भी technical reasons है, अगर मैं उसको उस डिटेल में जाऊंगा, because हमें justification bytes होती हैं, so आप कितना उसको bytes को adjust कर सकते हो, कितना आप उसको स्टफ कर सकते हो, जो फ्रेम रेट है दैट इज 125 माइक्रोसेकंड, अगर उसमें कोई डिस्टरबेंस तो नहीं आ रही है, वो फ्रेम रेट चेंज तो नहीं हो रहा अगर 4 ट्यूटोरियल लोगे। सो देयर आर डिफरेंट होल वर्ड टू इट इफ यू डू दैट। So that is why it is having the standard fixed by ITOT and everyone has to follow that standard. So I think the question. In Tejas 1400, if the OFC cable and patch code is okay, but receive and indicator is receive LED indicator is in both the stations, what should I check? So Satish will cover these troubleshooting steps with you. So Satish, are you there?
Yeah, Vivek, yeah.
So you can take the last question if you want right now.
Yeah, sure.
I'm just ending my sharing. Satish will take it over from there. Satish, एक बार last question answer कर दो।
I will cover in the PPT. I have everything with me.
Okay. Over to you.
My screen is visible to everybody?
Yeah, Satish, screen is visible. You can please go ahead.
Okay. Good afternoon, everyone. This is Satish Yadav. I'm working in the network.
Is visible, but the voice is very low.
Hello.
You just please put your mic some near to your mouth.
Yeah. Hello. Now voice is okay?
It is clearly visible, but your voice is really very, very low. It should be anyhow. It should be enhanced.
Would request you to just to check your headphone because we are getting it very clear and loud and clear.
हाँ, या सतीश जी की आवाज़ बराबर आ रही है।
Yeah, okay. Good afternoon, everyone. My name is Satish Yadav. I'm part of the network network solutions group, which handles the operation and maintenance and post support, post sale support to the customer. So I will start with the maintenance and troubleshooting for this TJ1400 equipment. So what we are going to cover is the general guidelines for safety during maintenance, handling and storage of cards. We will see the overview of the TJ1400 phase overview. Then what are the maintenance procedure, some of the maintenance procedures which we need to take care. Second thing, in continuation to that, we will be taking some alarm monitoring procedure. Some question was there with the LED status. So we will try to cover maximum things from there. How we can predict the alarms, or we can predict the failure, or we can take the corrective steps based on the LED indication. Then we will have a troubleshooting part wherein we will try to analyze how we can troubleshoot the failures, then do's and don'ts. So starting with the general guidelines for of safety during maintenance. So some of the guidelines is that we should, to prevent our personal injury and equipment damage, only trained and qualified persons should be allowed to work on the equipment directly. So we should avoid people who are not properly trained, or so that the equipment and equipment damage is avoided, as well as the personal injury is not happening to that person. second thing is we should avoid wearing loose clothing so that the our clothes doesn't get stuck anywhere in the chassis openings or the rack or any other point. If possible, we should wear safety glasses if we are working near the optical source, as it is hazardous to our naked eyes to avoid damage to the eyes from the optical power sources. Next, we should try to wear anti-static bands or shoes or clothes while working on the equipment to avoid the static discharge to the equipment and to avoid the failure of the component of the equipment. We should avoid directly looking into the opening of optical fiber or the equipment optical connectors to avoid the damage to our eyes from the optical source. Then we must ensure that the floor on which the rack is installed should not be moist, and power cables extensions are not kept on the ground, and it should be undergrounded or routed properly through ladders, and power cords are not kept here and there or lying on the floors to avoid damage, personal damage to the person working in the site. To avoid these power cable related things, we should never assume that the circuit is disconnected from power source, and we should disconnect all the power, disconnect the power from the power source to before installing or removing a chassis, or if we are working near the power supplies. So these are some of the guidelines which we need to keep in mind while doing the maintenance of the site. Then some of the guidelines which we should follow while the handling and storage of the cards is when we are handling the card, we should avoid touching the component side or the pin connectors of the component, so that to avoid the static discharge to the components. And if we are doing this cards, faulty cards or working condition cards can be repaired whenever they are declared faulty. If the static charge gets discharged in the component, the card may result in permanent damage and it can go beyond repair. So ओके 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 नहीं ठीक है, मैं उसको एक बार रिपीट कर देता हूँ. तो फॉर द जनरल मेंटेनेंस हमें जो है मीन्स इक्विपमेंट डैमेज प्रिवेंट करने के लिए और हमें खुद को कोई प्रॉब्लम ना हो, हमें कुछ इंजरी ना हो, इसलिए जो है हमें जो है वहाँ पे जो ट्रेन पर्सन है या जिसको हम साइट पे काम करने के लिए भेज रहे हैं उसको एटलीस्ट सम बेसिक ट्रेनिंग दे करके ही हम साइट पे भेजें. सेकेंड, हमें जो है लूज क्लोथ्स जो है कपड़े हमारे जो है एटलीस्ट वी हैव टू टेक केयर कि हम जो है जो कपड़े पहन रहे हैं वो कहीं पे काम करते वक्त हमारे रैक में या किसी और पॉइंट पे स्टक ना हो, इसलिए लूज क्लोथिंग्स को अवॉइड करें. ग्लास, अगर सेफ्टी ग्लास हम यूज कर सकते हैं तो सेफ्टी ग्लास यूज कर लें, सो दैट कि हमारा जो पैच कॉर्ड से ऑप्टिकल सोर्स आ रहा है या पोर्ट से ऑप्टिकल सोर्स आ रहा है वो जो है हमारे आंखों को डैमेज न करे. अगर एंटी स्टैटिक बैंड, शूज या क्लोथ्स अवेलेबल है तो वो हम उसको पहने. इससे जो है हमारे बॉडी का एंटी स्टैटिक चार्ज जो है, स्टैटिक चार्ज जो है वो इक्विपमेंट पे डिस्चार्ज नहीं होगा और हमारे इक्विपमेंट सेफ रहेगा, डैमेज नहीं होगा. हमारा जो साइट कंडीशन है, साइट कंडीशन प्रॉपर हो, इसलिए हमें ये इंश्योर करना है कि हमारा जो फ्लोर है वो मॉइस्ट ना हो और जो हमारे एक्सटेंशन केबल्स हैं या कॉर्ड्स हैं वो प्रॉपरली ग्राउंडेड हो या लैडर पे से जो है उसका प्रॉपर रूटिंग हो, सो दैट कि हम उसमें हमें उससे कोई डैमेज ना हो या साइट को कोई डैमेज ना हो. और साथ ही साथ हमें ये कभी एज्यूम नहीं करना है कि जो पावर केबल पड़ी हुई है या कोई केबल पड़ी हुई है वो सोर्स से डिस्कनेक्टेड होगी. वी हैव टू इंश्योर, हमें इंश्योर करना है कि वो केबल जो है उसका पावर सोर्स बंद किया हुआ है. तो कमिंग टू हैंडलिंग एंड स्टोरिंग ऑफ द कार्ड, जब भी हम कार्ड को बॉक्स से अनपैक कर हैं या we are taking out from the equipment, we have to ensure that we don't touch the shoulder side of the card or component side. We have to handle it simply from the plate, ताकि जो कार्ड है उसका कंपोनेंट हमारे स्टैटिक चार्ज से डैमेज ना हो, और अगर वैसा डैमेज हो गया तो आवर कार्ड कैन गो इनटू परमानेंटली नॉन रिपेयरेबल टाइप. For इसके लिए we have to ensure that we put the cards, whenever we are storing the cards, we put it in an anti-static bag. The cards, जो भी कार्ड हम जो है सप्लाई करते हैं वो एंटी-स्टैटिक बैग में आता है, तो we request you to keep that anti-static bag with you, so that whenever required, whenever the card is you need to store the cards or you need to send it for repairing or any other thing, you can use that anti-static bag for the storage of the cards to avoid static discharge to the components, and so that the card is safe. Whenever we are storing the cards, जब हम कार्ड को स्टोर कर रहे हैं तो we have to take care कि कार्ड जो है एक दूसरे के ऊपर जो स्टैक करके नहीं रखा हुआ है. Sometimes we are working on the site, we remove the card, और हम जो है उसको एक दूसरे के ऊपर एक हम स्टैक करने के लिए कभी रख देते हैं, तो we should avoid those type of things. अगर स्टैक करना है तो it should be properly packed in the box, and then we can stack on each other. Sometimes we are not having the original packing material. We bring some anti-static bags or any bag we are bringing, and we try to fit that box, fit that card into the box. So when we try to,
sir, thermocol separator can be used. Thermocol or foam separators.
Sir, if you are putting it in anti-static bag, then you can use the thermocol separator. That is not an issue.
Okay.
But first the card has to be put.
Sometimes I have to dump the 2 or 3 cards on my table. It's a wooden table. Then can I use thermocol separators? I am asking.
Sir, we prefer that you use the original packing box in which the card was supplied, and then you can dump on your card on your table one upon one, stack it. But if you are not having the original packing box, then please put it in the anti-static bag and then use the thermocol separator. It would be better.
Anti-static, sir. What is anti-static? Static charge will be blocked.
No. If you see, anti-static means our cards, when we are supplying in a polythene bag, which is anti-static bag. So the static charge will not be getting in that bag. So it will avoid.
Then any kind of dielectric bags, any kind of dielectric can be used as anti-static, no? Any kind of dielectrics, polythenes or something like that.
Sir, polythenes actually they carry static charge.
Oh.
Polythenes, if you want to simply check, you can rub the polythene on any oily surface, and if you try to connect anywhere, you will feel the charge. So polythene carries static charge. So if that static charge gets discharged into the component can get permanently damaged.
So sensitive.
Sir, all the electronic components are sensitive to static charges. It's not about Tejas card. Okay, sir. Second, the further thing is, whenever we are plugging out the module from the working system, as the module is working, so it dissipates heat, and the heat sinks are they are warmer. So if you take out the card, then allow it to reach the room temperature before putting it anywhere in any static bag or any place. Before shifting it, allow the card to commit to room temperature. It will take around 10-15 minutes, but we recommend for 30 minutes at least, so that we cannot touch and see whether it has came on the room temperature. But after 30 minutes, normally it comes to room temperature. So when you plug out the module, allow it to cool for 30 minutes, then only you transport or shift anywhere. So to protect the optical connectors of the transmitter or receiver, that is the SFP ports, whether it is stored anywhere or it is in the working system, it's better to cap the unused ports, which is already supplied through from the factory. So to avoid the flow of dust in the port and prevent it from damage. So whenever, if you are having any spare cards stored at anywhere, try to keep it in the original packing material, which is so that the card is properly stored and any damage is prevented. So during the storage, at the storage location, to prevent the cards from damage, we have to ensure that the accumulation of dirt or dust is not getting accumulated on the pin connectors, as well as the humidity of the room and temperature of the room is maintained proper, so that the PCB is not having any water precipitation to avoid the damage of the cards. So with this, some of the general guidelines, if we proceed further, we see that the this is the TJ1400 7-slot chassis, in which if we populate the cards, the numbering of the cards, whatever card you are populating in the system, the numbering of the ports will start from the right hand side, your right hand side, and it will flow to the left. So if we have SOT18, it will be something like 151, 152, 153 up to 158 would be the 8 ports of the SOT18. Here I have shown this SF1 card in the slot 1, which is having numbering from the right hand side. Physically you will see P1, P2, P3, but if you log into the system, it will show the ports as ETH 111, ETH 112, something like this. Whatever I have mentioned, it will show like this in the your node GUI page. So the maintenance of the equipment, regular maintenance is very much necessary to avoid some of the unnecessary failures, or if the maintenance is not done properly, if something is going on the site, some failure is taking place, and suddenly it will malfunction and put the system to shut down. So regular maintenance is very much necessary. So the regular maintenance is having 4 parts. First is the inspection, in which we physically inspect the site or the system. Second thing is testing and measurement. In this, what we do is some activity, we measure some parameters based on which we conclude whether the failure is going to happen or everything is going properly. One of the example of this is the room temperature or card temperature, which we can measure and see whether the prerequisite site conditions are met or not. Then it can be a replacement also. We have gone to site and we have seen that the patch cords have got bent and power is getting degraded, is one of the example wherein we need to replace the part or module or anything. Sometimes it happens like we have replaced things, but we need some adjustment. Like our STM1 SFP has gone faulty, but now I don't have the STM1 SFP with me. I am having STM4 SFP. So if I insert the STM1 STM4 SFP on both the sides and I want to make the existing link up, then I will need the readjustment of the cross connections in the nodes. So that is one of the example where we need to do some of the readjustments to put the original service in place. So if we have a maintenance plan in place, these are some of the checklists which we can do during our maintenance. First is the air filter related. So what we have to do is the air filter should be dust free. So if the dust gets accumulated on the air filter, one day it will happen like air filter is fully dusty, airflow is blocked. Now equipment will start heating up and it will reach to its threshold and suddenly it will shut down. So to avoid this thing, what we have to do is air filters should be cleaned periodically. So it can be adjusted from once in a 6 months or monthly basis based on the actual site condition, how healthy is the site, or whether it is the dusty environment or it is non-dusty environment. Based on that, we can make our maintenance chart, and we can go for the replacement of the air filters also based on the site conditions. Second is fan unit related. Just like air filter, fan unit should be also dust free, because air filter will act as the filter of the air, but fan will be responsible for pulling the air inside the chassis. So if the fan gets blocked or jammed with the dust, it will not be working, and the same thing will happen. The equipment will heat up and it will shut down. Further, we can inspect the site and check for the card temperature. So for this, we can do it remotely also, or we can go and log into the system at locally and check what is the temperature on the card. So in this, the basic thing is, if we maintain the room temperature properly and there is proper ventilation of the rack, so this will work properly, and all the systems will be working within the pre-required room temperature of the equipment.
Hello, sir.
What is the ambient temperature, sir? Temperature limit?
फैन यूनिट को से निकाल सकते हैं क्या?
Room temperature is around 24 degrees Celsius. So we have to ensure that the site temperature is 24 degrees Celsius.
That means AC should be provided.
Card can go up to 70 degrees Celsius.
जो फैन यूनिट को ऑन कंडीशन में निकाल सकते हैं क्या? एसटीएम ऑन है, उस कंडीशन में निकाल सकते हैं?
सर आप निकाल सकते हैं उसको, कोई प्रॉब्लम नहीं है, बट यू हैव टू एंश्योर कि जब आप निकालेंगे तो फैन इज इन वर्किंग कंडीशन, फैन मूव होता रहेगा, तो आप वो एंश्योर कीजिए कि यू डोंट पुट योर फिंगर्स इन द फैन. ठीक है सर. Then coming to the fiber patch cord side, sometimes what happens is we have laid the fiber patch cords from our equipment to the FDMS. Some new work is going on, somebody comes and lays another cable. So we need to regularly check whether there is any, to avoid external bends and external tension to the patch cords, so that it doesn't degrade and suddenly we don't get loss on the optical port. Continuation to the patch cords, we have sometimes what happens is our some of the patch cords we have removed, we were in use and now we have removed. So we have to ensure that we put a cap on the unused patch cords, and at the same time we put cap on the unused ports to avoid accumulation of dust in the ports or on the tip of the patch cords. And whenever we are inserting unused, we are going to use the patch cords which are lying unused on the site. So before use, we have to ensure that we clean the tip of the patch cords using alcohol and lint-free tissue papers. If you don't have any other, there are many options available in the market for cleaning of the patch cords, but this is the most cheapest solution available in the market. So we have to ensure that we at least we use this thing. The maintenance related to optical power is that if we take we start taking the capturing the power readings, receive power readings or between the sites. So this will ensure that we have a comparison with the fortnightly or weekly readings, that whether our optical power is the loss of the fiber is within the earlier captured reading, or it has degraded, or so that we can take corrective actions and we ensure that the suddenly the fiber doesn't get degraded. So this will have a check on the degrade of the optical fiber. What spare ports or parts are kept within the equipment or in our storage location, we should check it properly so that whenever it is required at the time of failure, it is available for use, and suddenly we don't get any surprise that whatever stored card is faulty. So this is related to alarm analysis. Whenever the system is working, we sometimes what happens is we get some alarms nobody has checked, and stack of alarms get accumulated in the system. So we should try that all the unused ports or whatever non-genuine alarms are there, that should be cleared from the system, for which there should be a proper analysis of the alarms, and based on the analysis, whatever non-genuine alarms are there, that should be cleared. So for some of the steps which we can take is we can check the current alarms and historical alarms. We can check for the fault systems and fault times to narrow down the fault scope. This will help in the clearing of the alarm. So some of the most common alarms which we get is fan fail, power fail, card fail, which is related to the hardware. The card fail can be any of the working cards installed in the system. Then there can be link related alarms like loss on the E1 port or optical port, LOF on the optical port, AU, AIS, Ethernet loss, or VCG related alarms, which may have occurred like we were testing something. We have concluded our testing and we left the thing as it is. Now the Ethernet port which was used, the cable has been unplugged, so it will start relating Ethernet link down and Ethernet loss. But that is non-genuine alarm because nothing was working on that. So we have to ensure that such type of alarms we are clearing from the system to avoid the unnecessary load on the system of carrying those alarms. So there can be alarms are related to temperature also. So we have to ensure that the alarms, we clear the alarms and only genuine alarms are present in the system. So we have to ensure that the earthing and power supply is proper. So there should be a regular check of the power supply voltage to the equipment, which should be within -40 to -60 volts DC, and the earthing resistance should be less than 5 ohms. So this is related to handling of the cards, which we have already covered in the general guidelines, that shoulder part should not be touched. So we will move on to the alarm monitoring thing. So basically, once we have completed the maintenance and the system is already working, so usually what happens is many of the alarms keeps on fluctuating, or we get many alarms on the system. So for the regular maintenance of the system, we need to have a regular alarm monitoring. So it can be done in two parts. First is from the NOC side. So at the NOC, the monitoring is done through the NMS software. So this ring shows one of the examples we have taken from Railtel network. We have taken this snapshot from their NMS, wherein this shows the complete network of the system which they want to monitor. So the advantage of NMS is we can monitor the complete network from a single point, from a single location. At any of the single location we can have our NMS software placed, and we can monitor the complete network. So second part is the monitoring of the system locally based on the visual indicators of the equipment. So these are some of the visual indicators. I will explain one by one. So when we go on a site, we are in front of the system, and we want to guess what is the alarm or what type of failure I'm getting. so that I can initiate some corrective action, or I can do the maintenance of the system, or I can correct the failure. So it can be classified into two types. First is the card related, second is the optical power related. So coming to the card related, except for controller card, if you see any card, there would be two LEDs, status and active LED, which will work on this principle of non-redundant card. So whatever I'm going to explain for non-redundant card will be applicable for all the cards. And when we, sorry, so when we say redundant, it is related to controller card only. So when we first plug in the card in the system, we insert the card in the system, then we will have the LED and active status and active LED will be in amber state. When the card completes its initialization, that is, the card is now booted up properly, both the LEDs will get green. Whether it is XCC card or SOT18 or SEF card, whatever card, it will have it will get the LED status as green. If some card was inserted earlier in the system, say in the 5th slot, we have inserted SOT18. That card was removed, and we have now somebody has went on site and he has inserted SEF1 card. So because the software knows that in the 5th slot I was having SOT18, now somebody has inserted some wrong card, so it will push, it will send one alarm of card mismatch. So that can be seen like both the LEDs will be amber, the card will not come up. So that is an indication that either the card is there is a card mismatch from the earlier used card, or another case can be the card is not booting up. In that stage, the active will be amber and the status LED will get red. So if the card is working and it has failed during the service, at that time the status will go down, it will start showing red color, and active will be in green color. If we have resetted the card, there is a reset button, black reset button on the card. If we push that button, the card will go for initialization, reinitialization, and it will be resetted. So at that time, both its LED will become amber, just like we have observed for the case when we had first inserted the card was inserted. So this will be applicable for all the cards, whether it is SOT18, SEF1, or whatever cards we are inserting, or XT cross controller related cards. Further, if the second part is related to only controller cards, when we are inserting redundant cards in the system, this will be applicable for only those cards. So the status and status LED will be applicable for this. The condition will be same, but only the LED status of the cards, the master card and slave card, will tell us which one is the master, which one is the slave, and what is the status of both the cards. So when we insert the card for the first time, both cards, the controller cards, will be in amber state. The status LED, active LED of master and slave will be amber. Once the card gets initialized, the status LED will get green. Active LED of the master will be green, which indicates that this particular card, either slot 2 or slot 4, whichever is green, it shows that this card has become the master. And the slave will have LED off, which indicates that this card is working as a slave. When there is a card mismatch, status and active of master and slave both will be amber. When the card fails during boot up, the card was inserted, but it has failed to boot up, the service status LED will be red, but the active of the master and slave both will be amber. When the card fails during the service, the status LED will get red, active LED of master will be green, while the active LED of slave was already off, since it cannot be a master, as we have seen in the point number 2, that active LED was already off for the slave. If we reset the cards, then if we reset the slave card, it will not make any difference to the status LED status of the master. It will only impact the LED status of the slave. The slave's status and active LED will become amber, while the master will continue in its original state, whatever it was in the earlier. But if we reset the master, then it will impact the LED status of slave also, because the whole system will go in reset. So at that time it will show amber color. So if we come on the SFP side,
That means, sir, the healthy condition is the second one. The card in service.
yes sir, the healthy condition is the second one, right?
Second one. And if we reset the system, then it will just start from first stage to second stage.
Yes,
If there
right,
is no
sir. Right.
all amber, then green, 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 and off.
Yeah.
Sir, one thing is not clear. There is active LED master and active LED slave. Again, there is active LED. So what is the difference between this
Sir,
active LED and active LED master?
this is in two parts. If you see the heading, when system works with non-redundant card, so at that time I have inserted one controller card in the slot number 2. Fourth number is not having any controller card. The system is working in non-redundant mode. So at that time, this table, complete table, this complete table will be applicable to all the cards. This part of the table will be applicable to all of the cards, including the controller card, which is alone. There is no slave card inserted in slot number 4, only slot number 2 is having one card, or vice versa, slot number 4 is having one controller card and slot number 2 is not having any controller card. Then this table will be applicable for all the cards. Now I have inserted one more card in slot number 2. So there are two controller cards in slot number 2 as well as in slot number 4. So one of the cards has to act as master, which is the working card. Second will be acting as a slave, which is the redundant card. When the master fails, it will switch over to slave. So at that time, this part of the table will come into picture.
Right, sir. Right, sir.
Okay. So coming to the SFP part, similarly, by looking at the LED indication of the SFPs also, we can figure out what is the status of the SFP ports or optical power being received, or the link status related to the optical power. So once we insert the SFP, the LED status TX as well as RX will be red. Once the SFP comes up and our laser port is on, we have made the admin up for the laser port. At that time, the TX LED status will start showing green color, while the RX the RX port will be in amber color. If
Sir,
there is no,
your voice was mute, sir. Your voice was totally mute. Can you please repeat once the second part? That is that.
okay. Now it is okay.
Yes, yes.
Yeah, okay, okay. So when we insert the SFP for the first time in the system, then the LED status of TX and RX will be red in color. SFP boots up and we have made the laser on, while still we are not getting optical power on the RX port, that is there is RX loss. In that case, the TX LED will show green, which indicates that my port is transmitting the power, and RX LED will be amber, which indicates that I am not receiving any optical power in the port. Now I have made the laser off, so TX will go off. It will not show any color. It will be in off condition. LED will get off, while my RX amber port will still showing amber color, which indicates that optical power is not getting received. In this second part is, I have made the laser on and I am getting the RX power from the on the optical port. In that case, my both RX as well as TX LED will be green in color. If I make the laser off, but power is still getting received, in that case TX will show off and RX will show green. So based on these indications, we can analyze the problem related to the optical power or SFP related issues from through the visual indicator. So hope it is okay with till this. So we have this flowchart which will help you to analyze whenever you get any service interruptions, how to troubleshoot. So what has happened is, you have got one alarm, equipment related alarm, which is related to some card, that is card failed, card failed to boot up, card mismatch. So in that case, if it is related to card, then you can reset, try the reset option of the card. If it helps, it's okay, else replace the card. If the alarm is not related to equipment or card related alarm, then check whether the alarm is related to temperature. If it is related to temperature, try to clean the fan or air filter. Try to maintain the room temperature of the room up to 24 degrees Celsius, or try to bring the temperature of the card within the range. If it doesn't happen, there is a problem with the fan or air filter, then we will have to replace the card. If the alarm which we have got is not related to temperature, check whether it is related to protection switching. If it is related to protection switching, we will have to troubleshoot that protection switching to resolve the alarm. If that alarm is not related to protection switchover also, then we need to check whether it is line alarm related or loss related. If it is a line alarm related, then we have to check for the optical power and correct the fiber connection. If it is related to optical power, then we have to check the line alarms reported, or loop the optical port and analyze where is the exact failure. And if it is related to the fiber patch cords or fiber connections, then we have to check between the two sides and get it corrected. If it is related to loss, then we have to loop the optical port and check whether the alarm is getting cleared or not. If it is not getting cleared, then we have to check the fault related of the site. And if it is related to the if it is getting cleared on self loop, then it can be related to the cable or interconnection problems between the sites. If it is the alarm is not related to this loss also, then it can be a lower order alarm. The analysis procedure is same by loop back of the circuit from one side to the second side to check what is the flow of the alarm in the circuit, and based on that troubleshooting we can locate the fault. And if the failure is not related to alarm also, then it can be a configuration issue, or we can check whether there is any loopback active on the ports. If all these doesn't help, then you need to get a level 2 level of support from the OEM, that is Tejas Support Center. So these are some of the do's and don'ts. We have already covered this in the general guidelines and maintenance procedure. If you still want, I can repeat the same thing. So I will repeat it once again. So the do's are: cover the empty slot with appropriate filter to prevent overheating and damage of dust into the chassis. And don'ts are: don't keep the unused slots open. So if we have to clear the air filters periodically as per the required environmental condition of the room, and don't use air filters which are dusty. Disconnect all the power source by turning off the power and unplugging the power cord before installing or removing a chassis and working near power supplies. Don't assume that cable is not having power. Keep the chassis clean and dust free before, during and after the installation. Don't install the chassis on sliders. When removing a card, the unit should not be replaced into the system for at least 5 seconds to make sure that unit capacitors have discharged. Don't touch the heat sinks on the unit just after removal. So that is from my side. If you have any queries or questions, please let me know.
अच्छा सतीश जी।
जी सर।
अच्छा ये कभी किसी स्टेशन पे जो अपना STM 4 है ना, तो वो कोल्ड रिस्टार्ट हो जाता है, तो इस पे जो है क्या प्रॉब्ली चांसेस हो सकते हैं, क्या हमें देखना चाहिए?
सर यूजुअली जो सिस्टम कोल्ड रिस्टार्ट होता है तो इसमें दो चीजें होती हैं। एक तो आपका पावर सप्लाई, जो स्टेशन का पावर सप्लाई है, डीसी पावर सप्लाई रिलेटेड इशू हो सकता है। और सेकेंड थिंग इज आपका जो है पावर सप्लाई इक्विपमेंट का पावर सप्लाई यूनिट रिलेटेड इशू हो सकता है। दोनों में से कोई भी फॉल्टी हो सकते हैं सर।
अच्छा, जो आप बता रहे थे एयर फिल्टर वाला, तो अगर उसमें डस्टी हो जाएगा तो वो भी क्या इस पे इम्पैक्ट करेगा?
सर अगर रूम टेम्परेचर, इक्विपमेंट का टेम्परेचर जो है ज़्यादा हो जाता है तो सिस्टम वार्निंग देना शुरू करेगा, कोल्ड रिस्टार्ट में जाना शुरू करता है। बट अगर वो आपका एयर फिल्टर इशू है तो मतलब 1-2 रिबूट के बाद सिस्टम बंद ही हो जाए, क्योंकि इक्विपमेंट ज़्यादा हीट हो जाएगा तो बंद हो जाए।
ओके।
वो बूट होके वापस नहीं आएगा, बंद इन द सेंस वो कंटिन्यूस रिबूट में चला जाएगा और वो फिर रिटर्न आपको रीचेबल नहीं होगा। जैसे कोल्ड, हाँ कंप्लीट बंद हो जाएगा, सर्विस पूरी डाउन कर देगा।
ओके।
यूजुअली जैसे 1-2 कोल्ड रिस्टार्ट आ रहा है तो नॉर्मली जो है 99% चांसेस हैं कि आइदर साइट का जो पावर सप्लाई आ रहा है उसमें कुछ फ्लक्चुएशन हो रहा है इंटरमिटेंट, या पावर सप्लाई कार्ड जो है डैमेज हो गया है, मीन्स फॉल्टी हो गया है।
ओके।
हेलो
सर इसमें एक क्वेरी पहले था एलईडी इंडिकेटर्स का, वो मैंने कवर कर लिया है। अभी इसमें एक कैन वी रिमूव एयर फिल्टर है, So yes, you can remove the air filter and we can clean. You have to clean it with brush and reinsert the air filter. How do we know air filter is filled of dust? So that we have to check at a regular interval, fortnightly or monthly, depending upon the site condition, and it is a visual indicator. Visually, we can see whether the air filter is dusty or not.
एक इक्विपमेंट हमारा बार बार रिबूट हो रहा था
जी सर,
उसमें मेमोरी कार्ड चेंज किया तब सही हुआ।
कौन सा कार्ड सर?
चिप होता ना उसका छोटा,
सर पावर सप्लाई कार्ड होगा।
नहीं इसमें जो आपका 45 कार्ड
वॉइस सर, वॉइस ब्रेक हो रही है आपकी सर।
सतीश, आई थिंक वो फ्लैश कार्ड के बारे में बोल रहे हैं।
फ्लैश मेमोरी चेंज किया तब सही हो।
हाँ, ओके। तो सर वो जो है कभी जो है ऐसे प्रॉब्लम्स बहुत रेयर केस में आते हैं कि जैसे फ्लैश कार्ड या तो फॉल्टी हो गया या सॉफ्टवेयर करप्ट हो जाता है, तो वो बहुत रेयर केस में ऐसे इश्यूज आते हैं सर।
उस कंडीशन फ्लैश मेमोरी क्या आपको तेजस को भिजवाना चाहिए या कैसे, क्या अगर वो खराब हो गई तो क्या है?
सर फ्लैश मेमोरी जो है वो हमारे जो इंजीनियर्स हैं वही रिप्रोग्राम कर पाएंगे, तो उसको आपको रिपेयर सेंटर को भेजना पड़ेगा।
वारंटी खत्म हो गई तो एमसी में नहीं, वारंटी खत्म हो गई तो क्या करेंगे?
सर वारंटी खत्म हो गई तो सर हम तो बोल रहे हैं सर एमसी ले लीजिए।
सर इसका पीपीटी जरा सा दे दीजिएगा, ये टोटल जो कंटेंट था, इट इज वेरी यूजफुल।
जी सर, वो हम सर के थ्रू शेयर कर देंगे। गुड आफ्टरनून मैम।
Good afternoon, Hyderabad sir.
जी मैम।
The Tejas equipment, sir, what since we are coming into deep summer, what are the regular complaints you keep receiving, sir, when the Tejas equipment is giving some sort of alarms? What are the observations you have found out, sir?
Ma'am, see, regular alarms can be related to even failure or optical port failure. So that means I cannot say that these are some of the regular alarms.
जबकि since we are summer, कैसे भी अभी हीट ज्यादा बढ़ रही है, आपके पास ऐसे कौन से कॉमन सी कंप्लेंट्स आती रहती है कि जो ये आपका तेजस इक्विपमेंट इज गिविंग एन कंप्लीट एरर्स ऑन द पाथ साइड आल्सो, कुछ ऐसा होता है?
मैम अगर टेम्परेचर बढ़ेगा तो सी LOF अलार्म तो पोर्ट्स पे आने शुरू हो जाते हैं और सिस्टम रिबूट में भी जाना शुरू हो जाएगा, तो दोज आर सम ऑफ द कॉमन ऑब्जर्वेशन।
That means due to heating
and due to heating, ma'am,
local and the path side also will be affected, right?
No, path side means the alarms generated from the equipment will be reflected on the path. LOF is generated from the equipment.
That means it does get affected. Now, so if local issues are there pertaining to the STM, it will affect even the connected node also will be affected, now, sir, in the path direction.
Node will be affected if the temperature, see, if the temperature of the controller card itself exceeds, then it will start rebooting and it will impact the whole system. So that's why we recommend that during means you have a regular check from the NOC. If you log into the system and you will go on the controller card, it will start showing, it displays the temperature of the card. So if we keep a proper check, and if we know that means at this particular site my temperature is going to exceed, we can check and we can avoid this.
Normally, what do you suggest, sir, whenever these sort of heating arrangements start coming up during the summer? What are your suggestions, sir? Because normally in prefabs we will not have AC units. What are your suggestions, sir, being on that side of the place?
Ma'am, we will suggest to use AC and maintain the room temperature. That
normally
is the requirement.
Normally it doesn't happen, sir.
No, Means
And I'm just adding on to that. So if you have a site which is non-AC site and the room temperature is not being maintained, then you can probably have this common arrangements like Satish is saying. You can just close the door, or you can have a gap between the equipments, like between the two racks and between the two equipments. The gap should be there so that air can flow out from that equipment. That is the best you can do. Otherwise, it has to be like AC site. Okay, if it is not an AC site, then the temperature, as Satish mentioned, that whatever the temperature range is there, that needs to be maintained. But as in common practice, you can just have a more gap between the equipments so that it gets the time, it gets the airflow gets there, the passage gets, and the equipment gets cooled down.
Because most of the places are having in prefab, not in inbuilt station limits where we can provide AVCs. So normally these things keep cropping up, all these sort of failures.
so means ma'am, I have seen some of the sites in Railtel also where they use fans, external fans also, stand fans, to keep the temperature within the limit for the equipment. So you can go for that workaround also if you don't have the AC.
Sir, actually during summertime, if even the gaps are maintained very good, but the temperature is not coming below 35 or 36 or 30. That is the main problem.
Sir, we will not be able to help on that part. Or else we will do one thing, we will check with the engineering if we have any solution. If they suggest anything, we will come back to them.
Sir,
That's very much required.
If we continuously use the exhaust fan or like this, a table fan, exhaust fan or pedestal fan, then the prone to getting dust because the wind is coming from outside, no?
So that's what I'm saying, sir. The ideal condition is we should have a dust-free environment of the room and AC should be available. But if we don't have the AC and we have to keep the system working, then we will have to compromise on some of the parameters, right?
Sir, one point more.
Yeah.
In most of the stations, we are actually not able to man the section always. Huh? Some stations are there which are not always provided with man. So we
Yeah, right.
We have to put the system with charger in load and float condition. Now, sometimes it happens that the terminal voltage goes very near to 60 volt. Now, if it by any means goes just beyond 60, will the system get stripped or some damage may occur also?
Minus 60, you are saying DC voltage?
DC.
So the system will switch off.
Oh, system will switch off just if it crosses 60 volt.
Yeah, it will switch off.
Everything has a breakdown voltage, I guess, huh? Maximum and minimum for every STM.
Minus 40 to minus 60.
Sir, in our STM1, even sometimes the voltage goes to 60 plus 61, like that. It works. It gives alarm, but it works. But I think it is much more sensitive.
Just to answer this, so this, as ma'am was mentioning, it is for all the STMs, ma'am, it is the power is related to one system. So whatever interfaces are there on that system, all will be affected. So voltage range, as Satish mentioned, has to be between minus 40 to minus 60. But as Biplab is saying that it works on somewhere around minus 61, minus 62, yes, it will work, but that is not recommended. And we can even sometimes go up to minus 65, minus 68, that support is there, but that is not recommended because we cannot guarantee any performance beyond minus 60. So beyond minus 60 is just the luck and the bonus that you have. And it may damage the equipment also, as Satish mentioned. So from the Tejas side, the recommendation.
So leaving apart Tejas, do you also look into the SDH and PDS levels, sir?
So this is SDH only, right?
Since Hyderabad division is working completely on FIPCOM, sir, so probably we may need some technical support from your end. So probably we request you to kindly give in your number so that if you have your spare time, we can have a little small gesture of clarifying our doubts, sir.
Yeah. So I'll pass on. So my number is with Mr. Mohan, and Mr. Mohit is there from our side, so he'll be in touch with you for this. And probably then he can pass on the questions to me, and then we can get in touch. Yeah. So because yes, the FIPCOM is there, we can surely interact with the FIPCOM equipment. So on one side you can have FIPCOM equipment, on the other side you can have the Tejas equipment.
I sorry if I may interrupt, sir, but actually I'm directly on this webinar, sir. We do not have any contact details in this. I got this link, so we were able to log in. So, is there any possibility that you can flash your number to me, sir?
Yeah, I'll just message you.
Thank you, sir. Thank you, sir.
In the chat window, I'll message you my number and my sales number.
Thank you, sir. Thank you.
So there was one question regarding the PSU and PFU, the power filter unit and the power supply unit. I just checked with my R&D team. So the difference between PFU and PSU is that in the PFU, but we are supplying you the PSU, so PFU is an older version. So the PFU, as was rightly pointed out, that it filters out the ripples and the surge in the voltage. And also when you get minus 48 volt from the outside equipment, from the DC equipment to the Tejas equipment or any other equipment, so PFU does not step it down and pass it on minus 48 volt to all the cards. While in PSU, power supply unit, as Satish was mentioning, so that PSU will step down the voltage of the system according to the requirement of the card, because some cards work at minus 3 volts, some work at minus 12 volt. So according to the requirement, it itself will step down the voltage at the power card level. So that is the PSU. In PFU, the step down happens at the card level. So that is the difference between the PSU and PFU.
अच्छा मैं कहना चाहता हूँ कि जो एक हमने लिंक भेजी थी वेबिनार वाली, उसमें एक फॉर्म की भी एक लिंक थी, है ना? तो प्लीज़ आप उसको भी फिल करिएगा, और जैसा भी आपको लिटरेचर या मैनुअल वगैरह जो भी चाहिए तो आप उसमें क्वेरी में डाल दीजिएगा, तो मैं सभी को सेंड कर दूंगा.
One small doubt, sir. Excuse me. Hello.
Yes, sir. Please go
Sir, in TJ1400 equipment, we are having XA10G and XA20G cards. If XA10G got faulty, I can use XA20G on that particular equipment.
So mix of XA and XA20G, you're saying?
Sorry?
Mix of XA10G and XA20G, you're saying, right?
Correct.
No, that is not
Is it
recommended from
possible?
our side. So it has to be either both of the cards should be XA10G, or it has to be XA20G.
Can I use both 20G cards on older 10G equipment?
Yes. So the shelf itself has no dependency on the
Directly I can replace, or otherwise any software updation
So
is required.
no. The check what we need to do is about the power card, the power filter unit over there. So that should support the XA10G and XA20G. So that much power is required. So we need to verify that whether if there's such any cases there. So just let our team know, and we will get back to you by checking the power cards on that equipment, and whether those also need the replacement along with it. But yes, you can do it. The shelf need not
Only
be changed.
power capacity is the difference between XA10G and XA20G.
No, cross-connect capacity difference is also there. The port difference is also there. The kind of ports are there on
Yes, so physically port configuration also is there.
But cross-net capacity is also different. For XA10G it is 15G, for XA20G it is 20G.
Correct. That is, I'm talking about suitability of the cards in a single equipment.
Yes, you can put any of the cards, whatever is required. XA10G, XA20G is not an issue.
No, you are telling you have to check power configuration also.
Yes, that's what I'm saying. Power configuration is the only requirement that we need to check. Otherwise, we don't have to check any other thing like chassis type and all that stuff. We don't have to check.
Okay.
So because certain power cards have certain limits, also what certain power they can, certain wattages, so they all are like
any specified wattage is there for any specified wattage is there for 10G and 20G?
No, it is not like that. Is a whole system wattage is there. So like one power card is named as DPU8, that is 250 watt. Then there is DPU18 and DPU23. Those have different wattages. So as you upgrade the equipment, so you require more power, and accordingly, this power filter needs to power supply needs to be changed. So for the DPU8, which is mainly being supplied in railways, it is 250 watt.
Okay, okay. 250 watts. DPU 23.
DPU23 is I guess 600 some odd watts. Just in your, I'll just tell you.
Any other questions?
सर कौन सा लिंक में लिखने के लिए बोले थे जहां पर पीपीटी के लिए रिक्वेस्ट कर सकते हैं?
आप जो अभी वेबिनार की जो आपको लिंक मिला होगा ना, उसमें एक फॉर्म का भी लिंक है, रिस्पॉन्स शीट है, जो आप उसमें डाटा फिल कर दीजिए, अपना ईमेल आईडी वगैरह जो भी है।
DPU23 is 500 watts. Hello, can you hear me?
Hello. 8 is 250 watts and 23 is 500 watts.
500 watts, yes.
Okay.
Which one is, sir, that http /railnet webex.com railnet? No. I think it is not.
So any more queries, or we can end this session?
मोहित जी, आई थिंक हमें कंक्लूड करना चाहिए।
Satish, Satish, there is one question for you. It's an important question. If critical alarm is available, what parameters should I check? Satish, are you there?
Yeah. So,
question is for you.
so here he has not mentioned what type of critical alarm he refers, because in our system we have classification of the alarms in critical, major, minor, and warning. So whatever affects, whatever alarms is traffic affecting, whenever the link is getting affected, that our equipment will show as critical alarm. So it can be related to card failure, link failure, or optical power failure. So depending upon whatever is the issue that we need to check and we have to analyze.
ये छोटी कार्ड जो है,
सर आपकी वॉइस ब्रेक हो रही है। जी सर, बोलिए सर।
SOT18 जो कार्ड है,
जी सर,
उसमें केवल मॉड्यूल चेंज करने से ही 1 या 4 हो जाएगी या और कुछ चेंज करना पड़ेगा?
सर उसको सॉफ्टवेयर से आपको कॉन्फ़िगर करना पड़ेगा। जब आप इक्विपमेंट में लॉगिन करेंगे ना, कार्ड पे जाएंगे तो वहाँ पे वो पोर्ट कॉन्फ़िगरेशन का ऑप्शन देगा। तो जैसा पहले हमने बताया कि उसमें अलग अलग ऑप्शंस हैं, तो वो आपको ऑप्शन देगा कि आप उसको 8 पोर्ट STM1 में यूज करना चाहते हैं या 4 पोर्ट STM1 में, 1 पोर्ट STM4, पहला पार्ट STM4 यूज करना है या सेकंड पार्ट STM4 में यूज करना है या STM16 में यूज करना है। वो आपको वहाँ पे ड्रॉप डाउन मेन्यू आएगा। तो जब आप उसको सेलेक्ट करके आप उसको जो है रिकॉन्फ़िगर कर देंगे, तो पोर्ट STM1 और STM4 में होगा वो डिस्प्ले होना शुरू हो जाएगा उसी सीक्वेंस में।
ठीक है।
और उसके ऊपर का, अगर उसके ऊपर आपने पहले से कोई क्रॉस कनेक्शन बनाया है तो वो सारे क्रॉस कनेक्शन आपको डिलीट करने पड़ेंगे।
ठीक है।
जैसे आपने STM1 में कर दिया है, अब आप STM4 में कन्वर्ट करना चाहते हैं, आपको डिलीट करके फिर उसको कन्वर्ट करना चाहिए।
ठीक है, सारा कनेक्शन उससे जो भी है कनेक्शन डिलीट करना।
जी सर।
थैंक यू।
This 1400 equipment with the XA1480 card, can I use for STM4 link?
जी, हेलो।
1400 equipment with the XA1480 card.
Okay.
Can I use for STM4 link if SSC have been changed?
1480 में STM4 पोर्ट नहीं है ना सर?
ये ना
विवेक?
ना इसमें 1480 में नहीं है. 1480 has STM1 ports.
STM1 port only, ना?
सतीश जी.
जी सर.
हाँ, एक क्वेश्चन पूछा है, आप चैट बॉक्स में देख लीजिए. ADHT मऊ.
जी सर, एक मिनट ना. One node OS STM4 4L is not accessible from NMS. In adjacent station shows exchange state. ओके. सर ये इक्विपमेंट में ना लॉगिन करके चेक करना पड़ेगा. ये इसका कोई आंसर तो अभी हम यहाँ से नहीं दे पाएंगे, क्योंकि वो दोनों इक्विपमेंट का जो है ओएस स्टेट आपस में कम्युनिकेट नहीं कर रहा है, तो इस वजह से वो नोड आपका अनएक्सेसिबल है.
सर फिर से बोलिएगा, क्या बताया आपने?
सर जैसे जो इक्विपमेंट्स आपस में कम्युनिकेट करते हैं और हमें एनएमएस पे रीचेबल होता है, तो वो ओएसपीएफ प्रोटोकॉल के थ्रू है. अगर मतलब कुछ फेलियर है या कोई इशू है उस नोड में और वो नेबरिंग नोड्स के साथ में ओएसपीएफ का स्टेटस जो है फुल नहीं हो रहा है, एक्सचेंज में है, तो वो नोड में उस नोड में लॉगिन करके एक बार चेक करना पड़ेगा कि वो क्या इशू है.
उस नोड में लॉगिन करके देख रहे हैं, उस नोड में भी एक्सचेंज स्टेट दिख सकता है.
सर वो वही बोल रहा हूँ मैं, उस नोड में लॉगिन करने के बाद उसका एनालिसिस करना पड़ेगा. क्या कई चीजें चेक करनी पड़ेंगी उसमें जो.
प्रोबेबली कॉज क्या हो सकता है?
तो सर आप एक काम कीजिए, एक बार जो है आप हमारे सपोर्ट सेंटर से बात कर लीजिए, वो आपको उसमें जो है हेल्प कर देंगे. कोई अगर साइट पे जाता है वहां से लॉगिन करके एक्सेस दे देगा तो वो लोग चेक कर लेंगे एक बार. मोस्टली क्या होता है कि सर जो डीसीसी बाइट्स हैं वो करप्ट होते हैं. डीसीसी बाइट्स अगर करप्ट हो रहा है तो आप अगर ट्राई करना चाहते हैं तो जैसे अभी अगर आपने DCCM बनाया है तो DCCR दोनों साइड में एक बार चेक करके देख लीजिए. उससे अगर हो जाता है तो ठीक है ना, तो फिर एक बार आप कॉल कर लीजिए सपोर्ट पे, तो वो एक एनालाइज कर लेंगे.
मिट्टी वहाँ की वो ड्रेनेज में चली गई और केबल शायद उसमें चला गया, उसकी ट्रेंच में. ऐसा कुछ हुआ या फिर उसने बढ़ाया, केबल कट हो गया. तो एडीएस की सर मुझे बोल रहे हैं तुम ग्रुप में लिखो कि मैंने दिया था.
तो मेरा खेल करता हूँ कि बोल वहां से, मेरा कोई मतलब नहीं उससे. कुछ है क्या प्रूफ?
और एनी अदर क्वेश्चंस? अगर हो तो पूछ लीजिए.
What is the basic difference between DCCR and DCCM byte? Hello?
Sir, can you repeat? Hello?
What is the basic difference of between TCCM byte and DCCR byte? Any specific reason for using that?
Satish, you want to take it or should I take it?
नहीं ठीक है, मैं बोल देता हूँ. सर डीसीसी आपने जैसे अभी विवेक ने जब प्रेजेंट किया था तो हमने उसमें दिखाया था कि एसटीएम फ्रेम में जो है आरएस सेक्शन और एमएस सेक्शन होता है और मल्टीप्लेक्स सेक्शन एंड रीजनरेटर सेक्शन. तो दोनों में कुछ बाइट्स कम्युनिकेशन के लिए दिए हुए थे. तो आर सेक्शन जो था वो दैट वाज स्मॉलर, तो उसमें 3 ही बाइट थे जो है, तो वो DCCR हो गया. 3 बाइट इंटू 64 kbps का बैंडविड्थ आपको मिलेगा. और अगर आप DCCM यूज करते हैं तो देर इज 9 बाइट्स इंटू 64 kbps. दैट विल बी द बैंडविड्थ विच भी जो आपके इक्विपमेंट के लिए अवेलेबल होगा फॉर कम्युनिकेशन बिटवीन देम टिल योर नॉक.
Okay.
दैट इज द बेसिक डिफरेंस.
So just adding on to what Satish said. So in MSOH, so if it is a multiplex session, there are 9 bytes and there are 3 bytes in regenerator section. Functionality wise, there is no difference. Okay. So functionality wise, both are same, but since it is a multiplex section, you need more bandwidth to be carried from the multiplex section to the NMS. So there are more bytes to it. There are 9 bytes to it. So if from the regenerator section, since there is no airdrop or no traffic engineering happening over there, so you need a lesser amount of bandwidth to reach to the NMS. So that is there are 3 bytes in that.
Okay.
Sir, for
Thank you.
multiplex section, it is MSOH, na? It is 5 byte. 5
It is
pro.
it is from D9 to D12. So
Oh,
that those are not mentioned in that. So the byte are from so D4 to D12 and D1 to D3 are in the RSH. So any other question?
Any other question, team? So Mohanji, I think we can conclude that.
यस यस बिल्कुल बिल्कुल मोहित जी
So
कंक्लूड
thank you
करिए.
very much Vivek ji, and thank you very much Satish ji for giving such a beautiful, informative and very knowledgeable presentation. And I hope it will be very useful to all of us who has joined. And once again, I would like to thank to all the railway peoples who have give us such precious times of yours and just join this presentation and give us the opportunity to take this presentation to all. So once again, thank you very much Vivek, thank you very much Satish, thank you very much Mohan ji for conducting this webinar, and all the railway peoples who have joined. Thank you very much once again.
थैंक यू मोहित जी. मैं तेजस एग्जीक्यूटिव को भी कहना चाहता हूं कि विवेक जी, यादव जी और मोहित जी तीनों को बहुत बहुत धन्यवाद कि आपने इतनी यूज़फुल इन्फॉर्मेशन
Thank you,
हमारे
sir.
साथ शेयर की. और मैं सभी को भी थैंक यू बोलूँगा जिन्होंने वेबिनार ज्वाइन किया, और उम्मीद करता हूँ बहुत से लोगों ने अपनी नॉलेज को और इन्फॉर्मेशन को इन्हेंस किया होगा. और ठीक है, थैंक यू.
Right. Thank you very much.
Okay, thank you, sir.
Thank you, sir. Welcome, sir.
A.
रिवर्स करिए इसको. में प्रेस कर रहा है कि नॉर्मल में? नॉर्मल करिए. बड़े बाबू से बात कराइए. साइड नंबर 2 पे जरा इधर करिए साइड.